Learn how to build a production-ready AI agent system designed to review code pull requests. You will explore a sophisticated multi-agent architecture modeled after the selective human judgment of a senior reviewer. IU Singh will show you how to develop the system component by component using an AI native engineering loop that addresses potential engineering failures, integrates robust verification gates, and leaves you with a reliable baseline to extend further.
Okay, today we are going to build an agent that reviews your pull requests. And here's the plan. What we will do, we will take the difference of your code which you have added or deleted. We'll give it to maybe OpenAI or Anthropic API key with a completion prompt. And in the prompt, we will write, okay, tell me what's wrong with this code. And hopefully expect some good comments out of that LLM. And okay, we can do something else as well. We can also add RAG. We can pull some relevant files from the repository. We can stuff them into the nice little prompt. And then we can call that production ready, right? If that's what you came here for, please close this video. Seriously, please close this video. There are 400 tutorials that do exactly like that, and none of them is the production-ready agentic system. Here's what we will do instead. And frankly speaking, it does not start with tech. It starts with a real senior reviewer who has 20 PRs to review today. And the quality on the first PR is not equal to the quality on the 20th one. And you might imagine some reason why. It might be fatigue. It might be inconsistency, it might be some human judgment, it might be some missed things in the 20th PR, or it can be anything which relates to a human. And I want you to think about it. The problem is not to have an agent that can review your code automatically or in automated way, but instead, the problem is the selectivity, which is which findings does the agent takes and which ones does a human judgment actually get spent on. Now that one sentence of selectivity is going to be the whole architecture and everything will fall around it. Here's the part which I will also care about is I'm not going to give you a finished game or finished diagram of your architecture that this is how we're going to build it. I'm going to show you how I thought about this process. And frankly speaking, it's kind of a loop that runs once per component. What we do is first we'll find a human system that has already solved it, which means watching how a senior actually reads a difference of the code which you added or deleted. Then we'll bring the code base context which a senior reviewer actually thought about building in that particular moment. Then what we will do, we will reason across separate concerns. For example, a reviewer might think about security. Maybe they think about quality, they think about correctness, they think about testing, they think about documentation. Every one of them is coming from a different mindset. And frankly speaking, they are very skeptical. They are providing evidence of the everything which they are talking about so that if at any point of time they get wrong, they can get back to it. And if you read those 4 statements from the engineering point of view, the code base context means retrieval. Separate concerns means it's not just one reasoner, it has multi-agent architecture. Every site which is having evidence, which means every finding which my agent will make must carry a rationale and a confidence. And the 4 agents which we'll design will not come from, okay, let's design 4 agents, but actually thinking from what eventually Howard human reviews. And then we will take one component of entire architectures one by one, and then we'll ask a single question to every component is what can go wrong. And what we will do, we'll think from 2 different perspectives, 2 different directions. The first one is the engineering direction, where it all can fail. For example, let's say you're working on the component of GitHub, which is GitHub retries the same delivery all the time. Maybe the security problem that somebody else is sending your request of PR, which is not GitHub officially. And then you have just 10 seconds to acknowledge to GitHub, but your agent takes 90 seconds. All of that is engineering direction. Failure modes. In the LLM direction, we have the, let's say, the model hallucinates. The retrieval pulls the wrong slices. Every single thing which our LLMs can go wrong. And then what we will do, for every component, we'll put those failures into 2 by 2 matrix. For example, what you know, you don't know, what you'll recognize when you see it, and what you have never ever considered. And we'll do that, and the design of the component will start to write itself. And then we'll move to the next one. For example, orchestrator, retriever, events, gates. 5 components will run the same loop 5 times, and by the end, we'll be having an architecture which is fault tolerance we have designed already till there. And only after designing the whole system, we will code. And frankly speaking, we'll not vibe code it like other people. We'll run our Genesis ritual. Genesis is in harnesses which actually give you an ability to maintain a state and to be able to consciously work with AI to be able to develop your project or to be able to implement your architecture. For example, a context graph with your invariants. How does a definition of a done which looks like? What each milestone will eventually contain and exactly what will the output of each milestones. And then the loop will drive the agent against that spine. We'll be having 5 different gates to build that particular loop and an independent verifier that actually verifies whether it has done the work or not. Along with it, we'll integrate systems where it literally asks questions whether you have understood whatever it has written or not. And we will truly show you how AI native engineering actually works when you actually be mindful about what your AI is doing. And by that point, you're not depending upon your agent to think and code. You're actually directing your agent and still having the full harness of how you're controlling the agent and what your agent is doing. You'll ship a real system. You'll have a multi-agents running in parallel. You'll be having a human approval queue, a full trace viewer, and a cost dashboard that is actually going to show you the economics of your LLM. But more than that, you will have the loop, and the loop moves. We'll point it at a correct previewer, an incident agent, and anything of that kind. And more than that, you'll also learn how to natively work with AI and still be able to understand what your AI is doing at every single point of time. So there's a roadmap in the description. So I'll end this entire course not by building the entire system, but giving you a baseline to build on top of it so that you can actually extend this project and natively work with it. So let's get started with our system design.
All right, guys. So let's get started with our actually designing the system. So first of all, before we even get towards telling you about, hey, this is how to think about, this is how to write the design, the idea of this project is to, of course, tell you that, okay, this is how you can design an AI peer review agent. But more importantly, I want you to be able to extend this to other problems. I want you to be able to extend this to other ideas by your own. And that's why I first of all want to share you that this is the lens which is behind the way we think about, this particular whole system AI peer review agent, which you can further generalize to any system which you're working on. Now, so we usually have this template and which I have created, and the first template and the first move is mapping the mess. So whenever we will go ahead and when we design the system as well, we want to document what actually happens today. I mean, if I'm designing an agent which reviews a PR, I want to see that what if that particular AI agent is not there, what is happening right now? What is happening without that particular solution, without that particular AI agent? Now let's assume why I do this, because as I say that if you remove a component from it, if you remove that, okay, you want to review a PR, so instead of an AI which is reviewing the PR, what you're doing, you're having a human to review it. That's what you're doing right now, given that we assume that there is no other AI PR review agents in the world. So if you remove that component, what is happening? What you want to do, you want to observe everything which a person is going to do. You want to write those micro decisions which a particular person is going to do. It can be literally anything. It can be, okay, these micro decisions. For example, let's say I will take a very simple example. In this case, let's say we want to build this agent, how a particular senior reviewer will go ahead, will look at what code, the micro actions he will take, the knowledge base he will recall, the knowledge base he will see, the architecture decision records he will see, the documentation he will see, etc., etc. So what is he doing at this particular point of time to review a particular PR? And then you write every single minute steps of that particular person doing it. Because when you do that, and then you will figure out, okay, this is the mess which we need to organize in terms of agentic design. And that's the first step. There is no concrete step. And I always tell this to people, is AI system design is just that there's some manual work going on. You need to look at every possible steps which a human is doing, even unconsciously. And then you pick that up, and then what do you say? Okay, fair enough. Now what I'm going to do, I'm going to go ahead and figure out which is mechanical, where human is doing his judgment, and where we can, put LLMs, where we can put deterministic ML, where we can put anything. So we need to figure out that this is what we're going to do. So the first step which we're going to do in this project is figuring out what happens today, right? And more importantly, I want to understand, okay, what triggers it? Basically, what triggers a senior engineer or some engineer to review your PR? It's like, okay, as soon as the PR is made, he will get some notifications on his GitHub or probably Discord alert or Slack alert, or probably some person is going to say, hey, I made a PR, can you review it? And then he will make a comment. And then, so we want to write all those minute decisions, and we're going to do that. And we'll explicitly say, okay, this is where the human is required, and this is the mechanical stuff is happening. And we'll also figure out where it breaks. Again, I'm not yet on AI. I'm just on humans reviewing the PR and figuring out what it does, how it does, why it does, and where human fails. That's the first step. Second move, I want to make it more explicit to talk about what is going to be my trigger and what is going to be my output. And more importantly, I want to just talk about one thing, is if a particular person wants to review a particular PR, what happens? He gets a Slack notification, he gets a GitHub notification, he gets an email notification, he gets some person saying, hey, can you review my PR? Can you tell me that, okay, I have made a PR, can you please go ahead and review it? That's what the trigger which I want to give to my agent is. I want my agent to be triggering its workflow at a very precise trigger, and it should be a very precise. For example, the way I mean by precise is, I want to take one example. Let's say that you're building some insurance approval agent which approves whether to give the insurance to this person or not, right? What happens is, any email which comes in, what will trigger the agent? We don't want that claims comes in. That's a very vague trigger. We want a very precise trigger. So in that case, it would be a claim which arrives at this particular email ID and has a keyword such as claims. Similarly, in this, we want that, okay, anytime a PR gets posted, we should be able to create some GitHub webhook and use the GitHub webhook stuff to be able to get this on our Slack. And that particular PR by that particular person probably can be one of our trigger. Now, it's not just about having a trigger. We want to output. For example, into our insurance claim example, we want to be able to say, okay, it should be able to produce some output, right? Even in this, what it will do, it will say, okay, code, eventually a structured PR review is posted. The way a human would do is a structured PR will eventually get posted. Now let's assume, like, there are several types a person will eventually think about a particular PR, or maybe any GitHub PR which eventually gets made. The first point is that it should be able to think in terms of, okay, because my PR is posted, I should be able to test across the verticals, whether it is readable, whether it follows the security principles, whether it is, the test cases has been added, whether it actually confirms and works based on architectural style. There can be multiple parameters on this particular engineer might be testing the PR, might be reviewing the PR, and then he will make a comment. And then the person will come, the one who makes the code, and then he will come to this engineer and say that, hey, and clarify if something was not clarified to an engineer, or fix it and then sends it once again. Now, there can be also possible cases where an engineer needs to even revisit some other people, right? I mean, who is more senior to him, so that he can understand if he's not able to understand anything or if he's conscious about anything, right? So he should be able to go ahead and post that. And if it is an PR open source, let's say that if it is a PR of a big organization, they have a lot of employees and is an open source GitHub, right? If a particular engineer finds a very big security vulnerability, it should not be able to go and say, hey, this is what is going on, right? It should not be able to literally point out the security vulnerability right away. It should eventually go or raise something behind the scenes, basically not in the public, but more importantly, raised to the directly via Slack chat or something. We don't want to talk about what is a security issues publicly into an open PR. People can actually misuse it. So all of that eventually comes down to move number 2. And move number 3 is figuring out at which point of time. I've told you multiple steps. What a senior engineer will look at the PR, and then he will look at the code differences. Then he will look at its 4 to 5 parameters which he wants to test a particular PR based on whatever is the guidelines of testing a PR, right? There can be multiple steps which is involved, and we'll talk about those multiple steps in a bit. But we want to assign each step a component. A component can be our trigger, which means deciding that, okay, this particular component is a trigger. Now, if you want to fetch a data, if you want to fetch something, we will use, or we want to fetch let's say a GitHub review is posted. So we need to be able to, get to know whenever the PR is posted. So that's what our tools, APIs, and webhooks will come into the play. Let's say if you're looking to reading unstructured input or writing language and getting to know the intelligence generative piece, we'll use LLM. Let's say that we want to a score or anything where we want a deterministic point of view, we'll use deterministic machine learning. Or probably we want to use this, we want to look at the past knowledge bases, so the code can be huge. So we want to go ahead and say that, hey, what I want to do is I want to look at the code which is similar, right? Because if somebody has posted a particular PR, I should be able to look code which is associated with this PR, or even not just associated, but because of addition this code, what will get impacted. So I want to look at the similar codes, similar code differences into the databases, etc., etc. So I should be able to use RAG. I should be able to fetch such semantic code right here, right? And there can be a point where I don't want to have a human, AI. I want to have a human checkpoint. If it deals with the safety, if it deals with financial, if it deals with legal, I just want to have a human checkpoint. So these are few components. Now, move number 4, I will think about what and how much of this system will do it on its own versus how much it will defer to a human. For example, and I always tell this to the people is this is not a default in general. You cannot say fully automated system. You need to be able to think about that. What if something goes wrong? What is the consequence of your error? And I have a golden rule which I say that if your AI has to deal with, if your machine learning systems and AI systems has to deal with money, financials, legals, and probably your health, you cannot choose to have a full autonomy. It completely depends on your organization. And whenever you're thinking about designing any system, think about what happens if the error comes in. And I will tell you very honestly, even if you get 90 things out of 100, you get 99 things right. And that one error is right there, which is a kind of enormous consequence of having that error, you'll be doomed. Your system is not right. You need to be able to choose, and design by choice is telling, okay, this is how much autonomy I want into this particular system. And then move number 5 is we have a saying that everything will break. And this is a life advice as well. You need to be prepared for everything going wrong. You have planned something, assume that if everything goes wrong, you should be having some backup plans. You should be having some rollbacks. You should be having some fallbacks. You should be having all the plans ready, whatever happens. So similarly, we'll design the system and we'll go through every components and we'll say that, okay, this will break. For example, what happens when your LLM hallucinates? What happens when the API times out? What happens when we are not able to, GitHub API is down, GitHub webhooks are down? What happens if our agents who are giving some reviews actually conflict with each other? We'll talk about what does it mean to parallel agents in a bit. So I would ideally want, let's say, let's take an example. Let's take a very simple example. Is if let's say your LLM hallucinates, right? What will you do after that, right? Let's say if a particular embedding model is not working from OpenAI, it's down for some reason, usage is down, so your complete system is down, right? So you need to be able to retry again. Then circuit breakers, you need to be able to say that, okay, I will switch the models. I will switch the models to a different embedding models. It can be anything, right? So we want our components to fail gracefully, at least not better, but don't stop the whole system to work. It should be able to be reliable enough, and this is known as the reliability engineering, is to be reliable enough so that our models actually perform really well. Now, these are few things. Now, there can be multiple failure modes, and I will talk about few of the failure modes, and then we'll discuss it in detail what will fail in our project of AI PR Review Agent. The first one itself is hallucination. For example, the model will state something but falls in a place that matters, which means hallucination. And I don't disagree with you. And I always say that hallucination is a feature, not a bug. But we'll take it. Hallucination is definitely a consequence. If it happens, it's going to be very bad. So the way I will design is that everything which it should produce, it should have a citation requirement. It should have a fact share layer. It should also give the confidence. If the confidence is below a particular level, you want a human review to review that thing. And I will be designing it against these requirements. Then let's say that your model drifts has happened. For example, let's say that you are building some you build some AI agent. What happens that it was extremely good on your evaluation data set. And again, we'll design those evaluation data set. But let's say that was amazing at whenever you were building. But as soon as it went in the world, things changed. One of the prime example of this particular kind of system is, in this LLM case, it might be prompt, but if you're from the MLOps and core machine learning background, you know about this model drift. For example, let's say that you built an email spam detection system, right? What happens? Suddenly the hackers started changing their strategy of how they spam you. Suddenly the hacker strategy is just started changing how they put your system into a wrong place. Now, it was good when you trained and we built the system, but suddenly things were not going well. So I will have a monitoring dashboard. I will have alert thresholds. I will have a periodic training. I will have a periodic prompt updates. I will have a rules fallbacks. I will just sort it out for the common thing. So I will have those designed for that kind of problem. If my tool and API is timing out, I will have an external system. I will have a timeout and retry. I will have a graceful degradation on the partial data. I will have a circuit breaker on a dead service, and I will discuss about it. If you don't know about this timeout and retry, circuit breakers and all that, please don't worry. We'll be going through once we reach that component. For example, let's say feedback loop poisoning. For example, that let's say somebody given a feedback to your AI peer review agent. What happens that particular agent is not looking at your feedback and improving further. So we need to be able to look at and say that, hey, you need to improve yourself. So we'll have minimum evidence threshold that, okay, you eventually will use those feedbacks which is provided. Now also there are times that bad feedback is stored. For example, let's say a very junior engineer comes into the place and then reviews a particular PR into that particular tone in a very bad manner. Then your agent stored that feedback and then improved it. So we want to be able to make sure that the feedback is stored as good, right? Now, there are times when we need to also change. So if a particular feedback is not being used too much, we also need to decay our old feedback. Right? We don't want to use old feedback, which is no more helping and increasing our storage of our embeddings. We don't want to do that, right? For example, there can be orchestration deadlock. For example, let's say that you're having two parallel agents coming together and they don't disagree. So what you say, you eventually don't work. Let's say that usually when we talk about the parallel agents, you'll get to know that usually whenever two parallel agents comes into place, both has to give the answer, and then we have a merger which combines the result of both of it. Now, what happens if one of the agent do not give the output, right? So your merger receives just one input, or maybe both of the agents do not give any input, right? So your merger is also failed. So how do we do about it? How do we make sure that our orchestration deadlock is not happening? There is no dead end. We want to be able to build around system around that. Human bottleneck. For example, we want to make sure that we have our auto handling at most of the times, but we want to make sure that a humans clears it. I mean, escalation. So if it keeps on escalating every single thing, we don't want to do that. So we should have a priority look at the priority PRs. If at all the HITL eventually comes, we want to have the priority PR. For example, okay, this is what you look at. So we need to do the capacity planning. And this is an important problem, and capacity planning, which is, okay, how about, I mean, we are having, let's say, thousands escalations per day. Can my human review it? No, absolutely not. So how do you think about it? How do you prioritize? If it is really 1,000 escalations per day, how do you think about having a queue prioritization? How do you prioritize your PRs according to the business requirements, right? So these are the human bottleneck. Like you cannot have a technically one human to review 1,000 stuff in a single day. So you need to do a capacity planning. You need to look at the queue prioritization, which ones looks at the good one. And the another one is the almost right problem. The most of the times I feel that your agent is almost right, which means 90% correct, but it is kind of 10% subtly wrong. So we want to look at, we want to flag the low confidence output. We want to look at random audits. We should be able to doing maybe every 2 days, every 3 days to our system. We should be able to rotate our reviewers. For example, that we should be changing our models in general. For example, we should be also checking with wrong inputs. We should be able to check with new data, new inputs to be able to see that if it is really performing well or not, and then test how well it is performing, right? So these were few failure modes, and we'll discuss it in detail once we talk about our system. Still, please remember, we have not came to the system as of yet. Okay, so now talking about that, not every system eventually needs the same level of human involvement. And I always talk about if a full automation is required, you want it to fit where it is a routine task. It is a reversible task. The task is of low stakes. The human over there can review it periodically. If it is a human reviews output, which means the system produces and human verifies it before it goes out, which means that we're dealing with the reputational stakes. So it just makes a draft and then does not sense it and waits for the feedback. Human handles the exception, which is going to be the one which is going to use in our system. Is system handles the easy cases and human sees the hard one. For example, the one which has on anomalies, the system which has a low confidence, right? Human decides and system prepares. For example, systems gets the all context and then human makes the call. For example, especially in the financial decision, this is an amazing stuff where you take all the data of a particular, let's say you're providing a loan to a particular person. You want to gather all the information and then get all the scores. And then finally the human is approving whether to do it or not. And then we have another one, which is full human with the AI assist. Now, if you understand what we are doing, and I want you to work on this, any system which you're going to work on that, is what is going to be the consequence of error, right? So let's say a wrong style comment is annoying. For example, it can be any stuff which is right there. But if you miss the SQL injection, which is going to be dangerous for your system, right? That's going to be dangerous. So if we are able to, if our agent is giving a wrong style of comment, is fine. That's not much of an issue. But if it is missing a crucial security issue while reviewing the code, it is going to be very dangerous. Reversibility. Can an auto-posted review can be disputed and removed, but a merged migration cannot be undone easily. So what is the kind of reversibility for our kind of system? The system maturity, which means new systems need more override, proven ones earn less. So is this a system already there? So we need to give him more human right? So these are a few factors, for example, the consequence of error, reversibility, and system maturity, which you look at designing any sort of system. Now, if you start with more human involvement then you think you reduce it as the system proves itself. And that's what we mean by system maturity. Is let's say that you build the system and you increase and I always say to the people, it's fine even if it takes a lot of human to build an agent. It is good actually because you're going to look at your agent very, very consciously. And as the system matures over the period of time, you reduce the human involvement, rather than recovering from removing it, which is rather than it making expensive mistakes. And I'm not telling this just because I'll tell you a real story. At Secondary Labs at SBL, we had an amazing conversational agent which used to go on LinkedIn and have a conversation with the prospect. And we had a very good big client and one of the biggest in the United States of America. And he eventually came in using our platform. And what our agent did, our agent reached out to his prospect and customer, and then he scheduled a dinner. And the person was in Netherlands. Basically, the customer was in Netherlands. But I mean, we did not imagine that our agent will set up a dinner. That Netherlands guy eventually was a good founder. He came for a dinner. And then maybe after 9 hours, that particular guy got to know. Understand, this happened in less than 9 hours. All of that. Which means that Even if it would have happened at least 2 days later or 3 days, that was our assumption, right? That even if it sets any dinner, it will take at least 2 to 3 days to schedule anything. And by the time we'll catch it up and then we'll say no for that meeting or reschedule that meeting. But 9 hours, we would have never believed that would happen, but that happened. We got doomed. And after that, of course, SPL improved itself on more grounding responses. And you will talk about assumptions registration towards the end. Why assumptions? What actually happened? That, okay, our assumptions failed, which means our system failed because our assumptions failed. If we would have actually made the system in a way to say that, no, anytime, even 1 hour, even things can be set up, we would not have made the mistake, which means a system failed because an assumptions failed. So basically, having the right assumptions about your system is going to be an extremely important problems and design issue, which we'll be having towards the end. So the way you think about it is cognitive design. And that's what we're going to do in part 1, is spend a lot of time in designing the cognitive structure. Then how do you do the system architecture? What is your architecture? How do you retry? How do you make a system reliable? What technology stack are you using? And most of the time I see people, they're like, hey Ayush, let's just go ahead and use, we'll build our system using LangGraph. Let's just go ahead and let's use Postgres, a QDRANT for a retrieval. Let's just use any vector databases. But there is a certain cost and gain in deciding what technological stack which you want to use. For example, when we talk about choosing our where we'll store our memory, we talk about 3 different databases. So the cost is obviously cheap, but maintaining those 3 different databases, for example, reliability, failure modes, and all that thing is going to be very expensive. So we want to choose something which is a little bit in the cost, but actually we need to just maintain one data store rather than maintaining 3 different ones. And then why are we doing that? What is the gain of that? What is the sacrifice of that? That's how we choose a particular framework. Choosing a particular framework is not a big deal. Frankly speaking, I think people should not be dependent on the frameworks. Frameworks are very easy to learn. For example, we'll see 2 types of things: which data stores to use and how to store, and thinking procedure to eventually what to use. Then we'll talk about, okay, which orchestration to use, whether to use LangGraph, whether to use a Temporal. And then we'll talk about, okay, what architecture level we should use. We should talk about modular monolith architecture, or should we talk about microservices? What happens if we do it microservices right now? What happens if we do it modular architecture right now? What happens that, okay, if at all? Then we talk about, okay, how easy it is to shift to another framework. We don't want to design our whole system around one framework. So all of that is our system architecture. We want to build in that particular manner. And then we have this other phases, which we'll talk about as we go. All right. So now what we'll do is, now you understand a little bit about the mindset which we are going ahead with. Now what I will do is I will give you the first principles itself. And I always say that first, to design the system, to understand what we are doing, we said, okay, what if an AI PR review agent is not there? What my human is doing? My human was technically, we were able to create a steps where it was failing, how it could have failed. We write down every single thing. Now we need to think about is, before even we do that, we need to think about, now we'll start to implement every design template, the mindset which we produced is from the first principles, is why this system exists, how a senior engineer will review a particular PR, and how do we map the mess to an agentic system, right? And then what kind of memory. So you'll see that transition happening from our mindset to actually writing our design. And please understand, most of the times it's just basic look through. That's why the experience matters, right? You want to understand and you want to interview that person who's doing all in all. So let's go ahead and work on our part number 1, the first principles. Principles is going to be a very interesting conversation, and I'm going to take probably a lot of time discussing about the first principles. So whenever we think about, okay, hey, let's design a system, let's say a PR review agent, or let's design a system which, or any kind of agents, most people will start, okay, how do we build it? Okay, we should put a rate limiting, we should put a security, we should put observability. All of that is very, very important. I'm not neglecting that level of system design. But the way I think about this is, system design has a lot to deal with product engineering. Is that you're literally, until unless you have a specified problem, but again, if you're designing an overall system, it again comes down to a very simple thing, which is how do you engineer it? And the best way to engineer it, what if it is not there, right? Whenever we were designing an SBL, right? Even SBL, okay, what if SBL is not there, which helped us to design our vision? But technically speaking, when we were designing an SBL conversation layer, we were talking about what if that particular thing is not there, what happens? So similarly, what I want to do is I'm going to talk about is why it exists at all. And if you answer it, and once you answer it, the architecture becomes almost obvious. And my students will put that in comment box and they will know it, because if you remove something from here, you won't get it, right? So you will obviously feel the pain. And as I say, necessity is an feature of invention. That's where is the mother of an invention. So we'll create that necessity intentionally. Now, the thing about it is basically why this system exists at all, right? Which is, let's say that you have a team, and obviously this is a very, very basic understanding that what happens if a team is without an automated review. So if it is a big team, every pull request waits for a senior engineer attention. For example, you cannot get it reviewed for any mid-level or junior engineers. You need to be able to make a review by the senior. But the resource you have will be very scarce resource. For example, PR will be queued for hours and days. And I have honestly noticed when I was at my days at Artifact or ZenML and other search organizations, it used to take me at least a week to get to get proper comments on my PR. Now what companies are doing, they're having CodeRabbit type of PR review agents, giving them the instructions of how they want a particular PR to be reviewed, and then that particular agent is at least doing the basic job in figuring out, okay, this is where you need to fix. So basically, I mean, that's what, but previously it was pretty slow, inconsistent. For example, if there is several senior engineers, they might be looking at the same issue or another issue on another day, etc., etc. And then let's say, and I'll tell you, let's say that you start at one setting and then you start review and doing some work. By the time you go to the 10th, you will notice obviously that you fatigue your basically ability to do with the same energy, with the same intelligence, with the same mind at the 10th point will be very low. So what happens because of that inconsistency occurs. So that's what the fatigue means, is the 10th review of the day is not the first, which means the 10th review is the intelligence and the level and the quality of review is not equal to what it did with the first, because human has a tendency or way to get fatigue, right? And if the cost if no reviews happens is that, you know, people spend a lot of time in doing that thing. So if we let's assume that if we just remove this and we can feel the problem. Similarly, whenever you work on any sort of system, remove that thing and then think about what the problem might come. Then think about, okay, an automated reviewer exists to solve exactly one problem, which is reclaiming senior reviewer engineer attention by automating the mechanical part of the review, so that my human part is reviewing at the actual thing which it needs to, rather than doing a lot of basic stuff, or probably something which could have been caught, or to maintain the inconsistency, or to not have the fatigue. So technically, we don't want to build a system which does an automated peer review. Instead, we want to have an agent. What it will do, it will reclaim what senior engineer attention by automating the mechanical part of the review. An extremely important statement. What we technically did when we talked about this particular issue of what is happening, technically the issue is not, hey, I just need automated PR. If you notice, the issue is all about the senior engineer. And this is one such example. There can be multiple, examples, but in this example, it was a senior engineer's point of view that, hey, I want to get or reclaim my stuff. Even if there are multiple engineers, there can be inconsistency, there can be fatigue, it can be slow, it can be, if the cost of no review happens, is extremely huge. So technically the problem is not to design an agent which does reviews and PR. The problem is that how can I design an agent that reclaims my senior reviewer attention by automating the mechanical part of the review, and human spends is only the judgment where it is genuinely required. That way, your inconsistency will not happen and the fatigue will not happen because the person had just had to review the couples, right? And then keeps on giving feedback to the agent so it improves further. Now, a review agent is not a replacement for the human judgment. And I always say this to everybody. Whenever you design the system, don't think about that we have to automate every single part of it. We want to make sure that human judgment is very scarce. Can we do one thing is put up this particular situation so that human only focuses on where it actually requires. That's what the whole agenda. And this is the power of when we just listed out the problems. And if we want to look at the word selective, and again, a very, very, very important word, is it shouldn't, our AI agent should not surface a PR with n number of reviews, correct? It should only put out high value findings or something which is very interesting. It should not comment every single thing out there. So we should have the selective review from our agent on the mechanical part so that, and if it is possible, just give the high value findings where you're very confident. And if you're uncertain, we will escalate that to a senior engineer. And selectivity is the seed of this whole architecture, which means what will be given out of this system, what will be given out of this agent, why it is saying that, how are we making sure that it's saying the right thing, where are we putting HITL, where are we putting human in the loop, how are we observing it, how do I making it secure so that it does not give out anything bad, how do we make sure that lot of failure modes which we discussed, which we'll also discuss again, but how do we make it? So it's all about how do we make it so selective so that it works pretty well. And again, if we need to carry one thing after this section, which is L0, is the system optimizes for surfacing findings worth a senior attention and deferring the rest, not for maximal output. It should not just go ahead and blunt out the feedbacks. It should be only selective, not coverage is the first principle altogether. And the way we came to this particular statement is say that, okay, all right, let's remove what is not needed. And then you will see a new problem coming out of it. A new way to think about, a new problem framing will come out of it. So usually most of the system design has to be reframed in a particular situation. And that is going to be one of the most important things. That's why the first principles exist. So now we know, okay, we understand our problem statement. We understand this is what we think about it. Now what we want to do is we want to think about how a particular human would think about is how a senior engineer would review, right? So that's what I told is write down every single thing which a particular person would do, right? So before we do literally any technical part is when you're designing something which is looking genuinely hard, most of the times is just how we have already solved it in the real world. If you technically see what we are doing, okay, you can use this agent to find the PR. People were reviewing PR long back as well. Prepare an agent that creates content. People were creating content prior as well. Create an agent that approves a loan. Okay, people were approving the loan before. We want to do one thing. We want to look at the already solved problem and redesign it to make it, efficient, automated, or maybe where a human could actually just focus on what is judgmental rather than the mechanical part of it, right? Now, they do 4 things in a native which does not. If you just look at the prompt reviewer, which will, based on the prompt it's giving out. The first one is bring the code base context, which is an amazing statement. Is whenever the particular senior engineer is looking, they're looking at the knowledge base to look at what contradicts the past decision. If it's something based on architectural style, it's something based on decisions which this particular thing has not been done. Then they reason across separate concerns. There can be a security. Is it secure enough? There can be correctness. Is it correct enough? Is the test, has it covered the test or not? Whether a documentation passed, whether it is readable or not. Each with a different mindset, which means that they're thinking from a different mindsets for reviewing a particular PR. And then they stay skeptical, which means they do not assume the difference is correct. They cite the evidence, which is this is wrong because line 40 can be null here, not looks off. It's not just about, saying that, okay, this assume the difference is correct. No, they can say that this line can be impacted because that line can also be impacted. So we want to make sure that, and citing evidence is making sure that, okay, this can be impacted, not something this looks off. Nobody can review and fix it if it just looks off. It should be a very, very good evidence across it. So if you think about it, what we are technically doing, we are saying bringing the code base means the agent needs retrieval so that it retrieves the right code base context from the whole repository according to what PR was made, right? So if the PR made, so we want to look at the things which is similar, but also look at where it can also impact that code base. Then something we have known as context RAG and all, which we'll discuss. Then it should reason across separate concerns, which means that we should not have just one agent to talk about. We should have several agents, such as a security agent, a test agent, a documentation agent, a correctness agent, 4 or 5 different agents, right? And then there should be some master agent which will take all the concerns and put that into up and combine their results. And so 4 people reviewing, and then there's one orchestrator which reviews everything, and then there's final one which combines the all the agents output, right? Then we want to say, okay, it stays skeptical and cites evidence, which means every finding needs a rationale and a confidence to say that this is why I said it. Now, if you really notice, we have certainly did not say, okay, let's look at the context and all. There was a thinking framework to come to this particular line. The thinking framework was, okay, how a senior engineer will review. This is how we'll review. So can we write that into a statement, right? For example, there can be a security concern. Could this be exploited? There can be quality concern. Is this logic correct or according to my database? What's untested? Missing edge cases, untested brittle assertions, coverage gaps. The docs agent will the next. So there are 4 different mindsets which is looking at the same time, right? So now, first we said that the problem from our architecture is we're looking for something that actually selectivity, which means looks at the high value findings and optimizes for surface findings worth a senior attention and deferring the rest, which means high confident PR should be reviewed and uncertain should be given to the senior engineer. All right. So in this L1, we say, okay, now what we're going to do, we're going to say 4 specialist concerns born from how a human reviews. So we're having security, quality agent, testing agent, and docs agent. Security agent will say that, hey, I'm going to test it whether it's secure enough or not. Call the agent where it matches my logic is correct and right according to my architecture, design patterns, writing code standards and all. Is everything covered? Is there any missing edge cases, etc.? And can other people read it? And this is going to be how we will design our multi-agent system. But now, we are still not there. Now, our next step was what? According to our design template, is mapping the mess. Is what happens on a PR today. So a developer pushes a commit, then it opens a PR and then waits. Eventually, a reviewer will notice from some notification. Context switches into the change so that it looks at the whatever the changes happen, reads the differences, sometimes pulls the brand to run it, leaves the comment, and then the developer reiterates. So what is happening is, if you look at the very specific waiting is a pure cost and context switching, which means switch the context into the change. We'll talk about context switching. What exactly does it mean with the help of an example? But if you want to look at everything a particular guy will do, you want to name 2 things. Is what is the trigger and what is the output. And trigger is very simple. A pull request made. So GitHub actually offers a webhook whenever a PR is opened and not, GitHub emits a pull request. So very precise, because if we just want to know whenever the PR is open, so that we can just go inside it and pull out the code differences, right? Pull out the whole repository and then pull out the comments from that PR guy and then use it for the review, right? So my input will be GitHub emits a pull request webhook whenever PR is open. The output is a single structured review posted back to the PR using GitHub pull request webhook with findings attached to the specific files and the lines. Now, please understand a very, very important word. Is this the word known as structured is a very, very, very strategic work, which means we are not just saying that, hey, it's a blob of prose or anything of that kind. It is a list of findings, each with a shape, which concern raised it, how severe it is, where in the code, why, and how sure the agent is. We are not just saying, hey, this is wrong. We are saying, where did it come from? Traceability, how severe it is, where in the code, evidence, citing evidence, and why that is, the reasoning behind it, so that we can ensure that this is the right reasoning. And the confidence behind it, which is the evaluation stuff, is how confident it is, so that we can choose to escalate this to human or post it. So if you look at the first thing, which is agentic type, which means output will contain agentic type. It can be security, quality, testing, which concerns raised it, which means what are the concerns? Was it security concerns? Was it quality concerns? Was it docs concerns? Then severity plus category. What is the criticals? If you have seen the demo, critical or information. For example, if it is a security issue, then it's a critical. If it's just a normal docs issue, then the information that this is something which is already there, right? Critical might be missing an edge case, very, very important edge cases. So we're looking at what is the severity. So in a particular review which will come out of it, which concerns raised it, how much severe it is, how bad, and what kind of is, and file, line, and the exact location, which means where it came from, what is the line, what is the exact location, so that we can look at exactly where it is. And confidence plus rational, which is how sure it is and why, so that we can first of all, confidence, which will drives the human review gate. But what happens if the confidence is wrong itself? It says 90% confident that let's post it, but suddenly we found out that, oh, it's not good. So it should have given to human. So we should have the rationale, so that it also explains why, the reasoning behind it, so that when we review why it went wrong, we should be able to go find what exactly happened, which is basically makes the finding auditable and disputable, and trace it back. What was the reasoning which was wrong, right? So if I generalize what we did over here, is what is the precise trigger, what is the precise output, and the shape of the object that travels between every component. This is the shape of our output, which means what is the agent type, how bad it is, what is the exact location, and how sure and confident it is, and why. Right? So if we carry our architecture after mapping the mess, is the trigger is the GitHub webhook. Webhook will say, hey, here's the PR. The output is a structured review. And the unit that flows through the system is a finding, is output, with the agent type, the severity, the category, where the files, confidence, and rational. All right. So how do we think from the industry standard? So if you think about what current people will do, is they will just use the difference of the code. They will have the LLM verify the difference, and then they will put the comments out. But we just identified that we want to be able to do several types of reviewing automation. That does not work. It's good for a demo. It looks for a good demo that hey, LLM is producing something, but there's no mechanism to it. First of all, we'll do several type of 4 rungs. The first one is linters, which means it cannot reason. So do we use linters, basically looking at a pattern match syntax or style rules to make sure that we have a proper linting of a particular review, which means intent, the logic, and all that, which means that it cannot reason about anything. It can just look at whether it is consistent patterns and styles or not even reasoning about intent, logic, and whether it tests. It's just, there's no semantically. Then we have another type of review automation is static analysis, which is data will flow and the type analysis, and then it finds the real bugs. Now, it might put out anything, which means that it might give you that you put several test cases and it'll find some real bugs, which is an extremely good one. But where it will fail high false positive rate, no code base wide judgment, and cannot read the documentation. We just note that there is some bug, which is still people might be doing. Then we have another type of automation where we single LLM review, which means one prompt judges the whole difference. What will happen in this? Pause the video and tell me. One mindset for 4 concerns, no grounding in the repo, and hallucinates with confidence. We don't have any auditing. We don't have, there is no there is just one agent which is thinking about from 4 different angles. It's just one guy. So as you know, if you give an agent too much of work, it won't perform well. It does not knows about anything about repository. It will hallucinate because the context will get bigger. Then there's no auditability. There is no observability. So the another agent is agentic fan out. Can be fan out and fan in. This is one of the agentic design pattern, which is known as fan out and fan in pattern. What does it mean? That you roll out a specialist agents. For example, to review a PR, we are rolling out 4 different specialist agents: security, docs, tests, and quality. And then we are fanning in. The fanning in means that, okay, we are combining by an aggregator. So this is the system which I want to use. Of course, I can integrate this. Of course, I can do this. Of course, I can do this for any small task, but this actually stands out. But what is an issue? We want it to be able so that it can orchestrate well, step by step, make sure that it's reliable, make sure that it's secure, make sure that it's failure proof, make sure the retrieval is nice. So we need to design a retrieval system accordingly, make sure that we store the memory somewhere, etc., etc. Right? So the way that we carry out is we'll be carrying out a parallel specialist, not a single prompt, right? Okay. Then the grounding problem. And again, we are talking about, we started with saying our senior review agent, and then we figured out, okay, now we are what we're doing. We're mapping that every component so that it can actually writing the solutions for it. So what is the grounding problem? In the mess we saw, a senior reviewer does not have this problem because they know the repo, right? Because they already know the repo, they have the context and everything. So if we give our agent a particular situation, which means a difference of the code, right? Can we give the full repository in the prompt? Which means, can we give that agent of my full repository? Absolutely yes, definitely we can give. But we cannot put our full repository in the prompt. So what we are technically doing, we are saying, can we give this ability for our agent to know my repo before even it reviews? So if we put out everything in the prompt, that will exhaust the context window and it will pull out an extremely bad thing. So what should we do about it? The answer is retrieval, which means for every difference, the difference is basically, I will again explain what is the difference. Difference is basically what you have added plus code or a minus code compared to your actual repo PR. Repository code. So you see that plus green signs and minus red signs. So that is the difference. For that particular review, can we fetch only the most relevant slices of the code base and put those into the prompt? This is also known as the context engineering. And we'll talk about this in detail, how are we putting it. Okay, so can we do this? So the grounding problem is solved. So what we are doing, we are looking at every specific problem from that mess, and then we are solving it. So retrieval is what will turn the stranger into the colleague, which means, hey, it is going to give you the ability. Now, and you obviously know this, right? Now, what kind of review or what kind of memory does review need? For example, we said that we want to look at retrieving the context. The grounding problem said we want to retrieve the context, but it can be a multiple. For example, if you think about from the engineer perspective, the engineer can have a multiple memories. It can be semantic, which means the code base itself, which means the functions, the classes, etc., which is right now, conventions, architectural records and all. It can be episodic, which means past reviews, what was flagged before, what was disputed, which means that before this PR something would have happened. And there can be a procedural review, procedural memory, right? Which means how this team like things done, which means what is the convention? It's like a procedural memory in general. So for the semantic, we want for the code base, we want a vector embeddings in the similarity search. So that what we can do, that we can, whenever a code base comes in, we can just compare the vector embeddings with our code base embeddings and pull out the best ones. Episodic, we want a time-stamped relation rows. We'll talk about the memory again in detail when we do the data engineering flow, because data engineering is going to be the very important part. That is the next part after the first principles. But time-stamped relation rows that in 2021, we could have done this, but recently 2022 we would have done this, right? So you want to look at this, after this point of time, what has happened, what was flagged, so that it can know about the episodic memories. And then procedural, for example, I like to eat dosa, right? Is a, I mean, semantic. Okay, this person likes to eats dosa because this has a protein and all. And frankly speaking, I'm gonna continue to have this, right? Similarly, it's a very small and high priority. That how I like things to be done. I like to think about reviewing a PR in this particular manner. That's my procedural memory. So every time a new a PR has to be reviewed, we want to make sure that we are context engineering it right using these kind of memories right here. So what we are saying semantic memory wants similarity search over embeddings, which means a vector store, so that we can pull out the best code which is similar to what we want. Episodic memory wants a time-ordered, curable rows, and procedural memory is small and structured, which means facts and the rules. And we have to write it. So we need to figure out where are we going to store the semantic, where are we going to store this episodic, and where are we going to store the procedural. Data engineering is the most and important part of the whole system. So if you think about, there are three types of data shapes. The first type of data shape is our semantic, episodic, and procedural. So we want a semantic memory of the repo, which will have our vector store. We'll talk about what tech stack and what we'll be using. Past reviews and findings want a relational shape, which is time-ordered stuff, which means basically timestamp relational rows. Then conventions and decisions want a small structured shape, which can be again. So we'll discuss about this again when we design the databases. All right. So how do we trust? Basically, when we talk about a human, it's very obvious that, okay, they have they say that, okay, at this line, at that line. So suppose the agent posts a finding, this endpoint is vulnerable to SQL injection, confidence is 60%. A developer disputes it. Now what? If there is no record of why the finding was raised, which context was retrieved, which prompt version ran, what the model returned, what it costed, we cannot defend itself. It cannot be debugged. It cannot be improved. If something can be measured, something can be improved. But if we don't have which context was used, what was the version of the prompt, what was the model which was used, what was the embedding model, what was the retriever which was used, what happened at that point of time, we want to trace it all along. So we want to make sure that we want to improve the system. So we want to audit, which means which is trust, will require third thing beyond reasoning and grounding, known as proof. Which means for every action the agent takes, every span of work, every LLM call, every tool call, every decision, it must be recorded as an event in a time order durably, which is one of the part of our observability plans. And see, I have not told you why the word observability directly. You have felt it why it was required. And that's what the beauty of feeling the problem and then doing it. Now, the single stream of events is what powers three things, which is a trace viewer. We should reconstruct any review end to end. If it has reviewed anything, we should be able to know what it did, what it retrieved, the way it did, every single traceability. We should be able to have an audit trail. It should be able to defend or dispute any findings. And we should also have economics, which means how much it is costing to run the entire system, the cost economics. While I'll have a separate designs coming all together in future, talking about economics, token optimization, how to design by keeping the token optimization in the mind, how to design by keeping the cost in the mind, so here we are designing in a very structured format. And see, it depends on the business. Today business says cost is not a problem. So your idea should not be on the cost. But let's say tomorrow somebody comes and tells, hey, cost is going to be a big problem. So even though you design the system, you'll design another deck talking about this is how I'll think about after designing the system. Okay, now let's design a system for optimizing our tokens, which is caching and all that. which is one of our thing which we'll talk about in the later phases. I mean, not in this particular design, maybe in the future designs. We have a lot of designs coming, which is going to be amazing. Okay, so we want to have an event spine so that we can trace everything. So what technology we can use? Any observability tool. We'll talk about that in a bit, which means that we want to make sure how much is costing, what is the audit trail, how do we trace it? That is the fourth data which is time series in a particular shape. We want to look at every single thing, carrying cost, latency, confidence, and outcome so that we can trace it. Now, if we need to trust it, we will be always also figuring out when not to trust it. Because if you remember our problem was we want to make sure that our agent does things right. So when not to trust it, your level 0 said, L0 said that system should be selective. L6 gave it the confidence field, which we trust and prove, which is how much confident it is. Now, if we say, okay, anything beyond this confidence, we'll put this to a particular human. We'll put this to a particular, escalate this to a senior reviewer. So if the confidence, if it is no critical, the action is post the review automatically. Maturity owns the autonomy. Even initially, if the confidence should be at 0.6, so anything below 0.6, you want to go ahead and, put that as an escalation. That's fine. But over the time, it should mature. Confidence below threshold, which is route to a human threshold, approval queue. Any critical finding, escalate, which means literally escalate any critical findings. Developer disputes are posted, which means the posted finding is not correct, which means record the feedback, which is reversibility and learning loop. It should also learn and then improve over the period of a time if somebody disputes that the agent answer is wrong. So we will implement the HITL gate, which is human in the loop. Then we have also discussed there are multiple failure modes. What if the hallucination happens? So for hallucination, we have the grounding, so that we have the right retrieval, we have rational, and then we have the confidence. So we are trying our best to not get this failure. Then we have this tool and API timeout, which is retrying with back off. Then we have circuit breakers. Then orchestration deadlock, which means the aggregator waits forever on a hung agent, which means our parallel agents, 4 agents, they are not giving any output. So my aggregator is waiting. So there should be a timeouts on every node. Okay, so that it should time out after a certain point of time. You have always seen how the timeout works. The almost right problem, which means the finding 90% right but subtly misattributed. So we'll be having, again, confidence threshold, HITL right here as a defense. Human bottleneck. The approval queues grows faster than the reviews clears it, which means this we should have the escalation rate monitoring on the event spine. If it is too much of escalation, which means that my agent needs to increase its intelligence. So we'll be having that monitoring so that my escalation is not too much. And we should also do the capacity planning if at all. Agent learns a wrong preferences from a few disputes. So minimum evidence threshold before acting on a feedback, which means some feedback was given from a wrong engineer, but later not every feedback is good. People say, right, do not take every feedback. You should take what makes sense. So we'll be having evidence threshold before acting on the feedback. And then, which is the invariant gap, which means let's say that GitHub tried once, but it failed. But then it retried the another time, which means that it can post 2 reviews at the same time. We don't want 2 reviews at the same time. If the reviews are similar, if 2 reviews are same, if it is not already into our system, we will not go ahead with it. Which is we want to dedupe before posting, which is making sure that we are not retrying on the same webhook, which is the reliability layer, which is retries, circuit breakers, idempotency, dedupe at the aggregator, everything mapped to the failure modes. Please understand, I have not told you why reliability is needed. We just talked about the problems, solutions came automatically. Okay, so finally we're getting towards the end of the first principles, and I hope that you're really getting it before we even think about designing our data layer. What we said is a pull request triggers the work. It is in-queued because the trigger must be acknowledged. I'll talk about what is it. It is in-queued because we're just saying, okay, it should be looked from the GitHub PR. GitHub webhook sends it. We store it somewhere. We'll talk about this very, very important statement in a bit. After the data part, we'll talk about this statement. An orchestrator fans out the work to 4 specialists, which is running in parallel, known as one of the design pattern we are using is fan out and fan in. Each specialist is grounded by retrieval over the code base. So we are grounding it using retrieval design because it will not hallucinate. Because if we don't ground, it will hallucinate. That's why the RAG was invented. The code base, the past reviews, and the conventions are 3 kind of memories, which means that we have 3 data shapes by which we should be grounding it. Each specialist returns a structured findings with confidence and rational. Then aggregate merges them and deduplicates them and computes an overall confidence. Then it applies whether it needs a human or not. Then posts automatically when confident, routes to human when not. Then every action along the way is written to an event spine so that we can trace everything. And the whole thing can be traced and audited and priced. And then we have a reliability layer which keeps step degrading to slower but correct path. Right? So we talked about 3 important databases, which is memory. We have 3 different memory: semantic, episodic, and procedural. So here, the code base, the current code base, the past reviews, where we'll store the past reviews, and the conventions, which are procedural memory. So where shall we store these kind of data sets, in which data shapes, and how do we design our data layer? And this is going to be another important part, and we'll interrogate, which is, you might be obviously telling, okay, for storing, our code base, we'll use probably some vector store. Then past reviews, we'll use some Postgres using timestamp. Then for conventions, we use another one. You might be noticing that it's a huge problem there, which means, okay, it's 4, but why 4? It looks good. Okay, we'll be having 4 different stores. They all have very nice capability. But what happens is a lot of times, as I already told you, is each comes with reliability, security, management, maintenance, and all that. If one fails, everything gets round the way. So how can we minimize fraud from the failures perspective? That's what we're going to work on. So we'll talk about that. You can just see quickly what exactly we have built. We have talked about till now. Then now, if we have the principles, how can we design our database, and we'll be using and how do we select a particular technological stack? And then after data, we'll talk about how do you assemble all the architecture which we thought about it. All right, so now we eventually went through our first principles understanding and how to think about the problem. We need to eventually come about data engineering, and we call this data models, and you can call this any type of shapes, because we talked about one of the most important layers in our problem and in our system is how do we store data, where do we store data? We have several types of data, so where do we store that, right? So we'll address that data model, and then eventually we'll try to assemble it using an architecture. So it'll be pretty short, but I'll take it ahead. So with respect to what we want to do. So basically, we saw that agent has over 3 stages in general. The first shape is our memory. Now, if you look at that memory, it has a chunk of code and past reviews and conventions that will help the agent understand a new difference. So basically, anytime a new PR is made, it needs to look at the chunk of code or something which is which it can call. So let's say if a new PR is made, right, it has some code. It want to pull out all the related code for that particular, or anything which is related to that particular code, right, from your repository. It needs to take out all the past reviews or conventions which might be related to those kind of we can really call that as searching for the right memory from your vector database. Now the second one is the truth. Now the truth means is basically over here is the findings. Basically, let's say that you made a PR and then your AI PR review agent reviewed that particular thing. It should be able to store somewhere, right? It should be able to store what was the GitHub review ID, what was if it was escalated to a human, it was escalated to a human, and eventually the findings and the GitHub review and any human decisions. And third is the time. For every span, because we want observability, for every time we should have every span, LLM call, what is the tool call, the cost, the latency, and the decision which eventually happened into that eventually to debug if something has happened. And from our design model, you understood why observability was super duper important. So these kind of things which we ultimately want to store. So there are three things which we ultimately thought to. That there are three shapes, basically the memory, the truth. Truth will be the one which eventually, once our agent does something, it should be able to store somewhere so that we can continuously audit and eventually see the reviews and pull it up in our front end or show it in somewhere, or maybe use that for a training purpose. So the memory is you can use somewhere like something like Qdrant and or any vector database. What it does, it embeds the code for semantic retrieval. So it uses some LLMs for the embedding, and then it embeds the code chunks so that we can retrieve it semantically. And then there is a different shape known as truth. Now what does that mean is the Postgres. So basically for truth data shape, we might end up using the Postgres, where you'll store the reviews, findings, human in the loop rows, or GitHub IDs. Then there's a third one, which is the time. Now here you'll store your observability things, for example, spans, LLM calls, tool calls, cost latency, etc., etc. Now, if you understand that, you will be okay, go ahead, let's create a three different data shape. But in most of the time, we try to over-engineer something which we should not. For example, for this PR, what code did we, retrieve? What review did we produce, and which model calls it expensive? So if we want to answer this one particular question for this particular PR, we need to go ahead with three different stores. The three different app has to query three different systems and then stitch the answer together in Python. Now what does that mean? It depends on your architectural style. But the cost of doing this is the more you introduce the, overall issues, basically more data shapes and more databases to be used into this, the more connections pools you need, the more backups you need to have. For example, what if Qdrant fails? What if Postgres fails? What is your one of the data shifts fails? What if something does not happen? When does the row gets corrupted? There can be multiple failure modes for the same thing. So for simple question, we are having three different maintenance overload to be still doing all of this issue. Now, if you understand, the question that is obviously is, can we keep the three shapes? We don't want to compromise on the shapes which we want, but instead of using three different, and still not be able to split them between three different durable database. Can we put it into some current store which can handle all three data shapes all together on its own, rather than having three different data store per feature? Now, obvious answer is you'll think, okay, which database is more popular? But we don't want the database which is popular. We want the one which contains all three. I don't want Postgres. I want all three reflexive stored, all three data shapes into one database itself. So we ultimately decided to go ahead with Tiger Cloud. Now Tiger Cloud is what it will eventually help us to give a managed Postgres compatible database, and then we will add the extensions which needs for AI memory and time series agent. Because it already has the Postgres compatible database, it gives us a managed Postgres compatible database, and then we can further add our couple of more important shapes such as the memory and the time. And frankly speaking, Tiger Cloud eventually does that pretty beautifully. The first one which we needed is vector search for the memory. So as I say that we are looking for something which can store our code embedding. It should embed our code, our main branch, and then put it up there so that it can, so anytime a new PR comes in, it should be able to pull the relevant code and then give it to our LLM agent. So PG Vector can actually help your Postgres to store that list of numbers in a real column. The column is known as code chunks. Let's assume that this is a code chunks, which is embedding, which is the embedding of this particular content. So your entire code file will be embedded. Now, whenever a new PR, let's say a charge customer comes in, it will look at all the things which is closest to this particular PR, and then it will take out the one. And I hope that you understand how this RAG works. And I'm not a big fan of teaching you RAGs right now, because if you're watching this video, I assume that you have understood a little bit about the RAG. But what I'm saying is, it will pull out all the relevant one which is very closer to this PR, so that it has the right context, rather than taking all the context from the back. I mean, everything code at once, which technically you cannot. You're only taking the one which relates, or which affects, or which gives the logic. Now, a lot of time, what happens, that your code file can come in millions and billions of embeddings if you're really working on the real database. So the point is, okay, how do we make it efficient? So PG vector itself, we have a PG vector scale from Tiger data itself, which eventually is like a fast librarian. What it can do, it can quickly give us the right set of, the embeddings right away. It knows where it is. So PG vector scale is an advanced version of PG vector itself, where it can actually add an index so that Postgres can find nearby vectors super duper quickly. And that's one of the favorite feature which I particularly like of Tiger data, and I've been working with it for a very, very long time. And then it has, and if you want to know more about the architecture and how it is built, feel free to go to the documentation. They have listed it very well. Then we are adding the disk ANN. It sounds complex, but let's say that when there are millions and millions of code chunks, you cannot search for every shortcut in the RAM forever. What it does, disk NNN gives the search structure on the disk and SSD itself, and still helps you quickly towards the closest matches. So what it is saying, what PG vector scale and disk NN is doing, is because your code can get in millions and millions and millions of lines and millions of embeddings, these two particular feature can actually, and these two particular advancement can actually help you out into getting the right embedding super duper quickly. So we had another shape known as time series, which is basically where we want to store, for example, for this particular chunk, our security agent reviewed, it started, the security agent called the LLM, the cost was this, and security agent ended for this particular chunk. Then for this particular chunk, the quality end started, it called, and it ended. So we want that kind of time series data so we can audit it, or we can have the observability. We can figure out when the LLM call was happened, how much did it cost, how long did it took, what decision was made, etc., etc., etc. So Tiger data itself gives something known as hyper table, which can store them as a time chunks behind the scenes. Now, for example, it looks like a nice little table, for example, something like this, which is agent events hyper table. But in Tiger, that actually helps you. Tiger data can actually store as Monday rows, Tuesday rows, and today's rows in a separate chunk internally. This is how it is going to be stored. And that becomes another powerful data ship itself. Notice that we are not creating a new database. We are having just one, managing just one, and then you just have to design your failure modes around this itself. Now, let's say when the dashboard asks for the last hour, it does not need to look for the entire database. It can look at the recent chunk instead of driving the whole history. Amazing point. Then we have a dashboard should not be able to call raw events from scratch every time it calls. If there are 10 million LLM calls, we should be asking, what did we spend today? We should not scan all our 10 million rows on every refresh. So we need to have those dashboards, right? We need to be able to quickly understand. Instead of going to 10 million rows, we should be able to quickly estimate what did we spend today rather than going to the 10 million rows. So eventually Tiger gives something known as continuous aggregate. Continuous aggregate is eventually a summary table that Tiger keeps updated for us. The raw rows eventually goes into agent event. So this eventually becomes super duper big in millions and billions and overall data. We should not be able to score and then figure out how many of we did. We eventually have this continuous aggregate all the period of a time. Such as
cost per minute, the P95 latency, the tokens total, or any such matrix you want to store. Now, the budget card can read your summary first. So basically, if you remember, we said we don't want to cross a certain budget, the economics of building an AI agent. So instead of looking at the whole table, they can just look at this particular continuous aggregate and say, okay, if it can just read the summary and say if the today's spend is already above the limit, it will block your LLM. It will not let it go ahead. So it eventually gives us one durable database, one backup story, one place to query, and one identity that connects memory, truth, and time. So previously we have three different databases. Now we have one store where we can store using PG vector. We can store all the chunks, events, which will eventually help us to store the time series data for the the observability, and then continuous aggregation and agent health and PR costs, so that we can monitor our thing very well, and even our agent for economics tasks, they can come and say, okay, did we not cross the other thing or not? That's right. Okay, perfect. Now we also have something known as Redis. Now Redis is basically, we'll talk about this Redis, but Redis will stay because eventually we want to skew our jobs into Redis itself. So if you want to go ahead, so before we start, and I will also have to make you do this particular thing. So so you can go to any link, and then you can go to the link which is provided. The Tiger Cloud can actually give you $1,000 in credits, and you can still use it for absolutely free for your project task, which shows the enterprise level project and the product which you're ultimately going to build. And frankly speaking, Tiger Cloud is only used in a lot of the enterprises, and if you put this in a project, it's going to be looking amazing. Now, you have to do these steps, but ultimately, when I'll show you that, okay, if you do not know how to do this, how you can instruct your coding agent to be able to tell you what it requires from your side. Okay, so feel free. So you'll be ultimately looking something like this. What is your Tiger database? What is your OpenAI key? And all that. We'll talk about what is webhook secret and private keys in general. So feel free to read your schemas the way it looks. But now I want to talk about, why Tiger Cloud eventually we are using. So instead of plain Postgres, if we were just about to store enough reviews for review road and findings, we should quickly use Postgres. But we also need a fast vector search over code embedding and efficient time series queries over millions of agents events. So what it does, Tiger Cloud keeps the Postgres programming model, but adds such as timescale DB, PG vector, and PG vector scale that can actually help you to be efficient, be time series, and do the fast vector search in general. And that's why we are using this. And one of the greatest thing which we can use this is because enterprises also uses this. And the reason why we are using Tiger Cloud over Qdrant is because the vector search is not the only question this agent asks. A peer review needs vector similarity plus repo filters, freshness, exact identifier matching, review records, cost records, and audit history. Which means that we want to be able to keep this everything at once. We need to be giving everything at once, which means that the retrieval result can live beside the metadata and the review trail, ultimately your hypertables and all that thing. Then you have this disk cannon I just discussed. When you have millions and millions of things, this particular algorithm eventually helps you to index more of the code base, your index on SSD, while still returning the closest neighbors quickly. That's why we're using PG vector scale for large vector memory, which eventually the other enterprises uses it. And as we discussed, the hypertables and continuous aggregates eventually help us to, one is to internally maintain the overall chunk so that we can trace it back, and one continuously keep us updating and aggregating the summary of tables such as cost per agent, latency percentiles, tokens, and per PR cost. So now, once it makes sense, I want to go ahead with architecture. And I will combine every pieces we talked about, and then we'll straight go in how to work with coding agent to be able to code this entire architecture. We have everything to architect and assemble all our thing.
So basically, the first step, which I talked about into my mental model, is that there should be some trigger, and then there should be some mess to fix the workflow, and then there should be some output. So to think about it, into these kind of systems, we want to have a trigger. Now, where does that trigger comes from? If you understand, the trigger is basically as soon as somebody creates a PR, our AI PR review agent in that particular repository should be able to go and write a review. That's our trigger. So technically, how do we think about it? So if you search on GPT or anywhere, you'll eventually figure out that a GitHub webhook will arrive, will get validated, and then it'll be queued. So we need to create an ingress handler so that it ingests the PR and then eventually says sure. Now let's understand in a different way. Let's say that you have, and this is for the people who do not know about the GitHub webhook. Let's say the PR gets opened. Okay. Now what you do, you first of all ingest it, and you'll think about, okay, how do you ingest it? So whenever you take something, you want to make sure that you're taking the right order. And if you're taking it from Amazon, you're making sure that it is collecting the right order, right? You take the order, that's it. Now you close the door, and then you do anything else. But first of all, you take the order, make sure that it's from Amazon, and then you close the job. We can talk ingest into that similar way. Similarly, if you want to make sure that GitHub webhook is Sunday, GitHub webhook will send everything. It will send PR, it will send like, it will send stars, it will send every single event which happened into that particular repository. But what we are interested in is we are just interested in PR. So we want to make sure that we are only taking the pull requests. So what it does, first of all, we want to verify that that particular thing is coming from GitHub. So we will take the signature on the payload, and we will reject any or anyone who is trying to forger before any work. And by the way, this is one of the security thing where we are ensuring whatever is coming to make sure that it's coming from GitHub itself and nobody is exploiting our system. Then it checks the idempotency key or unaltered key. I cannot pronounce this idempotency, but there is something synonym known as unaltered. So this altered key, which is basically a retry delivery, is basically acknowledges and drop together. It's like verifying your GitHub signature on that payload and your key, which is an unaltered key. It's like your OTP. You're verifying both of it, which basically is one of the defense so that nobody is basically messing up with your system. And then it will enqueue the job to Redis. And if you don't know about Redis, while I don't want to take the class of Redis right away, but enqueue is basically a process of adding a kind of a new item to the back of the data structure that follows first in and first out, which means it's like, okay, FIFO principle. So it's like adding whatever the things comes from. If they're new keys, it does not act in front of them, it adds after that. So that if the new PR switch is already there, it does not come the next time, it is already there. So it eventually queues a job that, okay, this is the PR which has to be reviewed. Where it does in Redis, ARQ. Now, if I don't want to take a session right now in what does and what you mean by why are we using Redis? Why are we doing this? But basically, Redis is where we'll store all the job, and it's like a scratch pad where every time a PR is made, it will get stored at Redis plus ARQ, which is ARQ stands for something like automatic repeat request. Now, what is automatic repeat request is basically an error control protocol which is used in this networking to make sure that there's a kind of reliable transitions towards unreliable channels. So what it does, it's like accepting the receiver send acknowledgement so the sender can retransmit or corrupted packets. Now the way it works is very, very simple if I want to understand, if I want you to understand.
It's basically telling, okay, as soon as the GitHub PR is made, it is going to take, okay, I'll match, first of all, that is truly coming from the PR by matching this signature with the idempotency keys, and then it will put that up into, it will queue that job into Redis and immediately return to GitHub, says, I'm all right. I have received the PR request. That's it. And the GitHub says, sure, close the door. Now, the reason why we are doing this, and I want to think about it a little bit, is why are we doing this particular, is why we cannot just take the PR, give it to the LLM, and then directly, give it back to your GitHub agent. Why are we queuing our job to Redis? Now, in real world, you know what happens? First of all, a lot of PRs will be made, so there will be a lot of queues. So you'll say, okay, we'll increase the number of workers, we'll work on it. But if you think about it, even there is a bigger constraint. The constraint is very simple. Is GitHub Webhook expects a fast acknowledgement. You should truly say, yes, I've received. Yes, I have received in about 10 to 12 seconds. I'm not sure exact number of a time which it waits, but for the acknowledgement. But if you have received, we should be able to immediately return. Because if you wait for your LLM to complete, it will take more than 30 to 40 seconds and GitHub will throw an error. So we're going to say, yes, we have received it. I'll come back to you once I have something ready, and then again, we'll queuing the job, and then it'll be coming, and then it'll be publishing up there onto that PR. But the reason why we are doing that is the GitHub PR is eventually comes in, it ingresses, and verifies, it queues the job into Redis, and then that PR goes to the orchestrator. The reason why we are doing that is again because it asks for I need to acknowledge fast, and sometimes a crashed orchestrator or any delayed orchestrator eventually may not be able to satisfy the GitHub condition because it expects the truly quick environment. Now, where does this break at 10,000 PRs per minute? Now, Q, which is basically the depth, is basically outgrows the worker drain rate. A single ARQ worker, basically the worker which you have, which will do the working job, will become the quick bottleneck. So what you're doing, we are using the modular monolith answer, is extracting the webhook receiver as a stateless ingress service and then the orchestrator as a separate worker pool. So basically there's one receptionist who will keep on saying, hey, sure, give me the order, hey, sure, give me the order, hey, sure, give me the order, and store it into the Redis job, basically a Redis database. And then it has a worker in the backend, which you call this an orchestrator worker, which has a separate worker pool in the backend. So basically one by one, this receptionist will keep giving to that particular chef to create the food, to build the food, to cook the food. So just imagine if you just have one guy who's taking the orders and then building the same food, he will mess everything up. So there's one receptionist. That's why we have a modular monolith architecture where it extracts the webhook receiver as a stateless ingress machine or service which stores something in Redis, which is ARQ. And then this gives one by one to this orchestrator, which is a separate worker altogether. So what does this orchestrator does? So we are using an orchestration platform known as LangGraph. And I want to think about it a little bit. Why are we using LangGraph as an orchestrator system? So basically, the orchestration engine, it defines the workflow as a directed graph of nodes, which is functions of LLM calls and edges, which is what runs next. So the design pattern we are using here is, here we have four specialists, right? Four specialists who is reviewing my code. So if you think about it, it's a quality, security, testing, and basically this docs agent, which is eventually doing from a different perspective. So are they dependent upon each other? Obviously not. So what does it make sense to use basically a good design pattern, agentic design pattern for it? Is basically fan out all your agents parallelly so that everyone can work parallelly, because nobody is dependent upon each other, my girl. Okay. Nobody is dependent upon each other. So it it eventually fans out, and then there's one accumulator which accumulates all the 4 workers. So if I show you the way it works, is the orchestrator eventually have these 4 agents, security, quality, test, which is running in parallel, and then there's one aggregator which merges dedupe and scores and then routes. It can either choose to go through, it will first of all go to the confidence gate. If the confidence of review is good, it will post on GitHub. Otherwise, it will give human in the loop. Right? Now, the way to think about it is that there were 2 different, orchestrator which we had to choose. The first one was the LangGraph and the second one was Temporal. And again, we are choosing this because it makes sense. Now, for example, if you want to use LangGraph, where it runs in our Python process itself. It does not need an extra infrastructure which you are coding. A Temporal is a separate server altogether, so that's why we are not going ahead with that. If you just want to use parallel fan-out because that's a selected design pattern, a LangGraph Big is the first class via the send API. Basically, there's one behavioral pattern which is already there in LangGraph. But in Temporal, it is supported but is heavier to express. If you want to checkpoint to the same Redis, basically we want to continue to keep on checkpointing. But Temporal actually have a very strong guarantees and built-in for the checkpoint so that it can start where it failed. But LangGraph, we want to checkpoint to the same Redis we already run for the queue. So we want to keep on checkpointing there itself. The LLM integration is LangGraph was built for these kind of things, so it has an amazing tooling integrations, but Temporal is very generic. It is not LLM specific. It is built for creating workflows. Maturity is okay. LangGraph is new, thousands of this unproven, but Temporal is very, very, very enterprise level. It is excellent at scale. Operational cost is none beyond the app, but here you need to manage your own server, you need to understand your own workflow shapes, etc., etc., etc. So for right now, for our worst case, we said, okay, let's go ahead and use LangGraph. But does that make Temporal a bad candidate? Absolutely not. It depends upon, okay, for the MVP development, we may use LangGraph, but if at some point of time we feel that we want to use Temporal, we should, without thinking, should be able to switch to Temporal. So another major decision, our code should not be framework dependent. We should be creating a single safe intercept, basically a discipline that makes a safe is a single abstract interface, which is workflow engine, which is an abstract class which has run the workflow, resume the workflow, and get the state of that particular workflow. And then you're extending this abstract class to any implementation which you want, whether it can be LangGraph, Temporal, or any other orchestrator which you want to use. So let's say if the scale demands that you look at Temporal after MVP, then you quickly extend your workflow engine, no code changes, because you have not built your entire thing on your LangGraph. You're just going to add a new class of implementation of Temporal, which is going to run 3 different stuff, which is run, resume, and get state, which is going to extend these 3 methods, and then we can use Temporal at that point of time. So the idea is always and always make sure that you're trying to not make it framework agnostic. You're trying to make it framework agnostic. And as I said, that this is what the architecture eventually follows. So this is what our orchestrator will eventually do. But we also need to do the retrieval design because we need to set it up with the right context. We need to set it up with the right context. Now, just wait for a second, and I want to think about one thing is the design of the retrieval and whatever agents which you're doing, it is not perfect. We might have a separate videos, courses on how do you design state level agents. How do you make sure that you perfect the quality of the agents? Right now, our goal is to create end-to-end system as an MVP so that you know. But each problem, when you say even a single security agent, what is the logic behind creating security agent? How are we managing state? How are we removing hallucination? How are we removing disambiguation? How are you making sure that it is basically not taking a lot of time? How are you making sure that whatever it is going to post is not unethical? It is basically ethical, right? So basically, even at high level design, you go at every single aspect. Right now, we just designed very carefully about, okay, this is how the ingest workflow should look like. In real world, you end up sitting and then figure out, okay, how does my ingress system work? You design your ingress itself. Now, once you go to the orchestrator, you'll spend a lot of your time in designing the logic of my security. How are you orchestrating? You may not choose to go with parallel. You may have a completely different type of architecture. Depends, man. I mean, that's why you do literature review. So in one of the videos which I'm going to work on is basically I'm going to show you that how do you make reliable agents, where we focus on a specific agents and write the logic. As of now, this is good for the MVP. Similarly, we want a retrieval layer. Basically, anytime our agent gets a PR, we need to be able to quickly retrieve the PR difference, get the embedding of that particular PR difference. Then, because our code chunks is stored using ANN search and FTS, we should be able to quickly merge it and please make sure Type Cloud is providing this. Merge this and then give it to the specialist. So basically, the PR difference is getting the embedding, and this embedding is compared to all the things code chunks which is available in the Tiger Cloud vector store. We are using disk ANN and ANN search and FTS to be quickly able to identify the top K and merge those code chunks and then give the code chunks, the related code, retrieved code chunks to the specialist. Every single specialist. Okay? Now, to think about another thing is your every single agent events, which is basically for our observability. That's why I said we also want to make sure that observability is up there, right there. So observability, we are using TimescaleDB hypertable, is basically a trace viewer, audit trail, and cost ledger. It should be able to tell us when the agent started and ended, what was the call, what was the cost to it, what was the, where does that issue happen, where the issue arised, what is, we can also keep on seeing a rising rejection rate per agent. For example, all the agents are keep on rejecting your reviews, which means not every PR review might be bad, right? So you say that, okay, something is going wrong, but suddenly you also see the developers keeps on disputing your AI agent reviews, which means that there can be another. So we need the observability up there. We have already discussed in detail why we are needing observability, but this agent's events will eventually help us in getting the right observability. So if you think about the whole system in general, the MVP, at least in the real world, which you'll see, is anytime the GitHub PR is posted, we're going to ingress very quickly using Fast API, which compares their signature with our unaltered key, idempotency keys, and then what I'm going to do, I'm going to post that PR and store that using in Redis using ARKey and queue that into our Redis job. And then the separate worker, please understand, this worker will go and tell to the GitHub PR, I'm done. But then ARQ worker will pick one job at a time. This orchestrator is LangGraph. It will fan out four different agents that will aggregate. It will show its confidence. If the confidence is okay, it will go ahead and post the GitHub PR. If the confidence is not okay, it will put this human in a loop so the human can go and approve and give comments and then further improve. And please understand, it is going to be deployed. We are deploying on Railway in general. So your Tiger Cloud and TimescaleDB, which is TimescaleDB, is a one-managed Postgres, which means that you're going to retrieve whenever the security, because we need to set the retrieve design, right? So basically, if the security agent needs the code differences, so we're going to use PR difference, this architecture, embed the basic ANN search and keywords, merge it, and then fan out this specialist. Similarly, we're going to use the PG vector scale. This events hypertable will be going to be used by our observability dashboard so that we can observe it. So basically, we're not managing a different databases. We're just managing a one managed Postgres database itself, which gives almost all our ability. For example, in the economics and tokens, in the phases, we want to develop PR cost hourly. What is the cost, right? And then if it is beyond our current cost, we may not go ahead with that.
right? So this is the whole architecture in general. Now, if I think about it, if I want you to tell very quickly how I really want to build this architecture, and I will tell you how I come up with these kind of phases. The first is the cognitive design. I always suggest to the people, ship the simplest version first. So we want to ship something, and then we want to write the system architecture. Here we have taken a chance of saying, okay, we're going to use modular architecture, and then the ADRs has like LangGraph over Temporal. We always want that this particular conference should go, something like this. So we want to store all our architecture decision records. And then you have the backend and API. Front-end engineering is basically a simple dashboard so that somebody can see which of the reviews were sent for the HITLQ. The backend API will basically our fast API, which will validate our signature and idempotency keys. The workflow orchestrator, which will fan out the 4 nodes in parallel. Then your LLM and reasoning, basically model routing per agent so that it can route your agent and prompt registry, because you want to know which prompt was used. And you also want to make sure, see what happens a lot of times, we are also having a prompt of every agent, right? Now we want to keep on updating prompt or logic behind it, right? So for example, for docs agent, we don't want to use Opus model. We want to use simple GLM 5.2. But for security, we want Fable model, right? So we should be able to route our models, right? So we ultimately saying, okay, that's one. Then we have a prompt registry, which is basically one prompt was good in this, and then we created another prompt. So that should be also, okay, this is the version 2 of the prompt, not override it, so that we can also trace the decision back if something went wrong. Our memory architecture, the Paragon PG vector scale, toolings, basically scope. Basically we should be sandboxing our thing. Evaluation, we should be, let's say that we are pushing the new prompts or new models or literally anything. So it should be able to at least pass our golden data set, which means that our new system should be at least better than the current system which is already deployed. That's what we mean by golden data set. And regression gate blocks. Observability will be using OpenTelemetry, which will land in the agent's event hypertable, and then we'll be ultimately able to observe and trace everything which is handled. The basically for security, we'll be having RBC enforced and audit trail immutable. For reliability, we'll be continuously implementing the retries, the circuit breakers, the idempotency verified under fault injections, so that we have our reliable model in general. We'll be having a separate session on how do you make reliable agents rather than reliable software engineering. And frankly speaking, we don't have the knowledge of security reliability. That's where the power of our Genesis kits comes. So Genesis kits is basically will give you all the required context to code with AI and give the judgment where it is required. Okay? Your governance, your developer experience, your CI/CD, your human in the loop, and your continuously learning. Basically, if quorum continuous aggregates, if there's something needs to be changed right away. So these are the few phases which we'll be focusing throughout the project. And frankly speaking, I may do few of the phases, and I will let you do most of the phases by yourself as well. Because the idea is, if you know how to code, and I will show you a generalizable version, that you can literally code this entire project, right? So I'm going to set up a project architecture right now on the machine, and then using Genesis Kit, and then you will see the power of Genesis Kit right away. So let's get straight into the implementation. We will go ahead and we'll start the implementation. Now, what I eventually want is, I have actually completed this project, coded this project. So I will show you a few phases, code in front of you, show you the way to think about, etc., using Genesis Kit. Now, what does Genesis Kit is? Genesis Kit is basically the loop that prompt itself. You must have already heard about this, something known as loop engineering. You must be already heard about this harness engineering while coding with AI, right? This Genesis Kit is the framework developed by me, and I would suggest you go to something as anton.co and then click on blocks and look at, I'll also put that in the description box below. There's one Genesis, which eventually talks about the loop that prompt itself, and the structural reasoning is a missing piece of Agentic AI. These two blocks are one of the most important blocks, which eventually talks about how to exactly work and code with AI in general, and how do we give the state to our agent. So you will understand basically when I initialize this Genesis into the project, you will understand this. But what I want is if you can pause this video right now, read these two blocks, and then come back, you'll truly understand what Genesis is in the behind. I want to show you a very quick thing. And to show you that very quick thing, we have something known as Agentic SWE Kit. Now, Agentic SWE Kit is one of the skills which will help us to take the domain knowledge of something like security engineering, reliability engineering, distributed systems. It will also, I will put up some screenshot of it, how it looks in Obsidian, but it has an enormous number of concepts stored in the LLM wiki ways so that it can explore the right concepts at the right time. And it is natively integrated in Genesis Kit itself. Now, Genesis Kit is basically that can actually help you to write, plan every single thing for your project. What I'm going to do, I'm just going to copy this entire full onboarding, which is basically you don't have to do anything. You just copy your entire full onboarding right here. And then what you want to do is simply come over here and, let's say you open Claude, and I always like this dangerously, permissions, and of course feel free to do whatever you want, and just click on enter. By the way, I am a big fan of Hermes. I'm a big fan of Codex. I'm a big fan of, I have all my agents running right now. If I just toggle this up, you can see all the panels, and my Codex, my Hermes, everyone is working right away. And I frankly don't want to, I just want to show using Claude, but this works literally anywhere. You want to use Codex, go ahead and use it. You Hermes, please go ahead. And frankly speaking, I'm the big fan of using Hermes. I'm not a big fan of using Claude, a terminal, or maybe even Codex. But nowadays, I'm trying to be very agnostic because a lot of my models are running on Hermes. Where I'm using, at least the Bedrock models, basically open source models there, and most importantly, kind of model routing. This particular Claude is specifically because I have a subscription, so it just gives a generous, and because I'm recording this around 3 a.m. in the night, so it gives a very generous, and nobody's using, so it just resets the limit by the morning. So that's why I'm right now using it. But very rarely you will see me using Claude. Their terminal, and not because I have any hate towards Claude. Amazing software, amazing stuff they're building. I kind of end up using something where tokens are less. I'm very consistent and very, very conservative towards how much tokens I'm spending. I have one simple rule. If you have generated one token, tell me what was the output of that. If you cannot justify the output, dude, fuck you out. That's my point of view. And sometimes Claude does misbehaves, and a lot of time I can just use something like Opus to orchestrate, and then probably use Klein. And Klein recently is giving a lot of free open source models at $5 a month, and actually get a lot of my work done using GLM 5.2, just having an orchestrator, right? So what I also do is sometimes have, let's say, if Fable, right now Fable is available to all the people, but you can actually use Fable to be able to go ahead and as an orchestrator, and sometimes and then use GLM 5.2 to write the code. So basically you're doing a lot of things from a cheap price. And at least we'll have a different session on how do we optimize for tokens when working with AI and coding agents. But right now Genesis Kit does beautifully it giving you the right context, the right state, so that you don't double write the code. Every time you start a new session, you will be able to use the same project again and again. You can start it, you can collaborate with your team without losing the context, without having the overload of the context, without your coding agent hallucinating, without coding agent doing whatever, without making you understand. We want to make sure that every tick which currently has a wall while we're working with AI. So first of all, I want you to understand that if you think that working with AI is like vibe coding, no, this is not vibe coding. Here you will take a lot of time in system design itself, and then create few steps, and then eventually come to the Claude itself.
So it's not vibe coding. It's basically how do you harness, how do you design loops, how do you design debug loops, how do you design research loops, how do you harness your model, what are the guardrails are you having, what is the token budget, how are you routing your models, how basically how are you verifying your models. For example, one of the things which Genesis has is a lot of times your model itself writes its own test cases, but here it will not write its own test case in general. It will verify, because why it does not write such test cases, which is just one feature of Genesis Kit, is that it's like verifying or writing the exam paper for your own and then verifying your own exam paper. You'll automatically write those exam questions which you're already aware of, because the teacher creates it, because teacher does not knows your reasoning, but knows, okay, this is the input and that is the output. This is the test cases which must agree. So what I'm going to do, I'm going to paste my entire prompt from the GitHub repository. And by the way, guys, this is an open source repository. Feel free to go ahead, contribute as much as possible. We want to make this popular. We want to make this a true state of working with any coding agents, no matter what coding agent you're trying to use, GLM, Kimi, any cheap model, any expensive model, it should be able to use that. And feel free to star it, and feel free to fork it, and then create a new pull request. We are happily accepting pull requests right now. So if you go ahead and shift it, but before even that, I just want to make sure that what model I'm using, and I'm 100% sure that it's using Fable, and yeah, it's using Fable. So I technically going to use Opus, and what I'm going to do, I'm going to paste this, and I'm going to do a very important aspect over here. I'm going to say, can you please make sure that you're not using Opus, you're just using Opus as an orchestrator or sometime planner whenever required. Spawn Haiku or Sonnet 5 agent to be able to do this task. Never spend a lot of your tokens on this itself. So always spawn Haiku, always spawn Sonnet 5 to do this particular task, even for the coding agents or materialize over the time. So go ahead, initialize .genesis right here in this project. Always use Sonnet to even do anything of that kind. Do not dump all your Opus tokens here. Now, it's a very important thing which I told is because it's in mechanical work, and you'll notice throughout the way that how I'm using these tricks, and but we'll have a separate session on working with coding agents in general. So I really don't want to. I don't like dynamic workflows, because it does not. It is not of my favor in general, because dynamic workflows sometimes done in parallel, but most of the times our projects sometimes are very dependent with each other, and that's why I'm very particularly against using workflows. But it's a beautiful one if you're truly sure of that none of these two agents collaborate with each other. So let's wait for some time it completes. All right, so where should the Genesis spine go? In Genesis, because it is our memory of whatever we'll do in the project, I'm going to do one thing. I'm going to say, okay, I'm going to use this folder itself, and I'm building an AI PR review agent, and I will slightly add a note, and sure, okay, let's just go ahead and submit the answers. All right, so it has spawned some agent. I'm not sure which agent to say it has spawned. Oh well, I think it has spawned Sonnet. All right, so it is doing something, and not something. I'm very sure of what it is doing. So it is basically making sure that do not write over an existing. If it prints no genesis yet, proceed and make a GitHub repository, explore the kit, run the graphizer, and then understand, and then run the gates. Now you'll see how particularly your genesis will work beautifully right now. All right, so as you can see, this HTML file is our teaching file, the notes file. You can always go there and see it. So basically you can see what it has created. The first file it has created is, a lot of files. And the first file, the things which is very important for us. You should see over here something known as done.html and implementation notes.html. Done.html says that this is what done looks like. Your agent is not allowed to touch this done.html. You're only allowed to touch the done.html, which is basically says, okay, this is something which no agent will touch. This is what you call as done, because a lot of time your AI coding agent can divert and change the goal as per its convenience. So you're not letting anyone touch this done.html. So that's why here it says scope. What kind of work is this? Is it a build from scratch and there's an existing code, or there's some incident we are trying to fix? There's a new build completely. So we should just say a new build. And then is this distributed? What's the runtime shape? Basically reacting to GitHub, possibly with a queue, real distributed, multiple services. Okay, so I'm gonna go ahead and having the webhook service, because we said that a long-running service reacting to GitHub webhooks, basically PR open and updated, possibly with a queue. Instead of having to give a lot of answers, because I think that we have already designed our system, so we don't want to give a lot of the answers, I'm going to say a lot of your answers, chat about this, a lot of your diagnosed cognitive answer can be found here. However, if you're restarting a project, this actually gives you a good way to think about. So we have already designed the system in general, and that's what we spend a lot of our time. So the gate 0 itself is to making sure that your done.html gets filled with exactly what you want to eventually see. And again, see the problem with this, what I don't like with Claude, that one time I stated that can you please go ahead and always spawn any coding agent, and not just Opus, but basically Sonnet 5 to be able to do a lot of its work. But as you can see, oh, okay, finally. Okay, so I think it has extract design doc for Genesis, so it is able to use Sonnet to be able to design doc and not using Opus for a lot of tokens, and I love it. Frankly speaking, somewhat Claude guys does it. Guys, I'm not saying that Claude is bad. I'm just saying they're just not okay in terms of what they do with me. So, right. So, by the way, you notice right now I just pasted my design pattern. That's why the design is very important, because cognitive job is one of the most important job, and that cannot be templatized because there are a lot of business decisions which is being involved. All right, let me read the design doc, and I will design the Sonic and pull out everything relevant to the rituals. Basically, there are 5 gates that can actually write your cognitive job. Okay, there's one specialist LLM agents, the one aggregator, the LM as a judge, the OpenAI text embedding 3 large models. Then there's new build, and there's runtime shape, which is basically distributed. As I said, that we want to use the FastAPI ingress, store it in Redis ARQQ. LangGraph worker will be spawned out, which will be 4 separate nodes. And I'm just verifying in this one aggregator, which aggregates HITL and posts back to GitHub. We're having a Next.js dashboard. We are having timescale Tiger data as a spine for our storing our several types of memory, and we're going to deploy on Railway. Amazing. The trust boundary is that we want to have webhooks which is matching with each other. The PR difference, which is basically untrusted and prompt injection. So we are also looking for making sure that none of the security stuff is happening. The LLM output should be always grounded, should be always confident and rational, and followed by our human in the loop agent. So we are done with the design. Pretty much great. So how should I build the 20 design into Genesis? Each milestone needs one exact. As I said, one of the beautiful part of the Genesis set is a lot of times your coding agent actually produces something and says, okay, it should work. But for this, we want to make sure that it has some sort of harness that it will call done. So which means after every phase, we want to make sure that it is going towards and basically through our, the style which we want, that's why it forces it to run a specific demo command that proves it works. For example, let's say that there is one, let's say a webhook ingress. Now, webhook ingress is basically the demo after completing this milestone would be curl signed versus unsigned. Okay, HMSC rejects, idempotency drops. So this is basically the demo. Then the LangGraph demo is trigger run, 4 nodes in parallel, kills the worker, resumes from the checkpoint. So basically, run the nodes in parallel, kill the worker, and then see if it reviews from the checkpoint as well. So that is another one. Specialist press aggregator, submit test PR different, one merged press distributed. RAG retrieval, hybrid query on code chunks, and all that. Then observability, fault inject, and all that thing, which is again an amazing. So now it says for every phases, we want to have each nodes. So I really like to do something of this kind because, we should be able to, so let me say, we should be able to, so tell me whatever you need from my side, like something you need my, keys from a GitHub webhook and probably Tiger Cloud keys and whatever you need. And by the way, also, give me step by step to get and retrieved those credentials and then to be put in the .env file. And probably we can skip. I want to do individually and have the demo commands individually because see, we may choose to. So do not spend a lot of time in front end. It should be very, very simple. Do not spend a lot of tokens in that. Very simple. It's just that I want to see there. We should prioritize our data, basically Tiger data a little bit so that we can sort the Tiger infra rather than that coming out of some time so that we can see what things are being stored. So let's plan in order where the parts which is not dependent, for example, Tiger infra, then we can eventually talk about. So even before Tiger infra, we can build that particular webhook ingestion, which is ingress service. And then we can build this Tiger infra so that all our infrastructure is sorted in the first place. And then we can go ahead and having this orchestration, the multi-agent and all that thing. While I wanted to make sure that you put it somewhere so that we can eventually get started on that front. And please feel free to tell me whatever you need from my side. Give me step-by-step way to get me up there. To have you give me the credentials up there. For example, you might need this Redis, Redis managed database. So, you tell me, which particular tool should I use? Which particular platform should I use to be able to give you, to basically store the jobs. And of course, I want free stuff right now because I'm not developing this production. I'm not going to scale this right away. See, it is going to do every single thing. Whatever we have said. By the way, it has not started.
it is still confirming. Okay, let me quickly go ahead and see the milestones, what it has created. So as per our plan, the webhook, okay, that's fair. Then Tiger infrastructure. So the demo command is something like this, that it should be able to figure out the Tiger. Then send webhook query cspan rows, which is basically every event spine, every action span only agent events. Then orchestration, which is trigger run 4 nodes kill worker resumes from the checkpoint. And we want to make sure that the external dependency over here is basically taking stuff from the Redis itself. Then specialist, so basically we want the OpenAI to be able to do a lot of things, which is basically OpenAI keys. The RAG retrieval, basically our Tiger plus OpenAI where you're retrieving something. Then HITL gate and post to GitHub, which is the test PR. The reliability, then minimal dashboard to see a lot of it, and then the evaluation. So pretty much okay. Now you'll drop this. So GitHub, it needs my GitHub webhook secret, which is quite amazing for M1, which is free and self-generated. I should be able to give you. Then it has Tiger Cloud for M2, which is the free tier, which means you already have the Tiger MCP connected in this session, so I can provision the database directly. When we hit I'll run, then it returns the connection string. But either do it by sign up with free ad and create a service copy. So I have already given you the step-by-step plan, so you should be able to quickly get your Tiger database, because since I already have it, you don't need to eventually. Then Redis, which is basically upstash serverless Redis, free tier, perfect for AIQ, sign up, which is basically when we use upstash.com, serverless Redis, and then we're going to put that into Redis URL, which is total of 30 MB, which you get for absolutely free. I'm not sure in this. Maybe you pick a region, you create a database, then you have a connection URL from the upstash itself. Then for OpenAI, for pay-as-you-go, pennies at the scale. So basically you're going to use API key, and I'm going to use Bedrock, whatever I have into my current system. GitHub tokens to post reviews for M7, which is GitHub which is basically I need to be able to post it back, right? So I should have something. So pretty much okay. And how do you want the Tiger Cloud provisioned? When reach empty. Okay, so basically they have MCP up there. So you can actually use Tiger MCP. So basically if you go to Tiger data MCP, and I'm going to show you right away, and they have an amazing MCP by, oh, okay, Tiger. All right, so feel free to go ahead and first of all create an account using the link given in the below, and then go ahead and try to authenticate, and then it should be able to install your MCP from there. Now MCP can actually do a lot of things. I mean, it can actually pull up all your things and run a lot of actions on your behalf. So sure, I mean, yes, we have a provision, so sure, right now that's okay. I can run it, but basically feel free to go ahead and have your same thing, whatever it asks, by the way. The best thing is that you can actually do whatever has your computer or PC. Right now I have this beautiful Mac, and it does have, I have a lot of background information, so I didn't really appreciate not going that, but feel free to go ahead and let's say that you go to this something known as console.timescale.create service, and then you can just go ahead and go to the Tiger Cloud and log in. So let's say if I continue with Google, And by the way, intelligentprogrammer123@gmail.com is 6 years old email ID. Amazing. So you go over here and then you can quickly go to create a service. So I already have it. So feel free to go and create a service right up here, and you select maybe the shed, you have that, and then you continue, and then you name your service. Then let's say I'm going to rename test, and then you create a service. Now, once you create a service, you can actually go ahead and your service is going to be deployed. And I'm not sure if that, but this is your connection string, which you ultimately have to give, which is ultimately it is asking is Tiger database URL, which is trying to create. So sure, use Tiger MCP, or you can find basically the connection string in Tiger in AI peer review. I'm gonna, because I don't want to give it once again, agent Tiger data folder and desktop as well if connection string is needed. By the way, guys, I use an open source model for dictation. I don't use Whisper. I don't know, I just don't like the attitude of the founders. So and by the way, am I going to pay you even a single penny to dictate? Are you serious? I mean, to dictate? The whole model is flawed, man. I mean, the world is going into a very weird space. I don't like whatever is going on. I mean, literally, there are a lot of free models, dude. Pay for something which provides value. To dictate? Do I really? Okay, I don't want to go there, but amazing. Now, okay, sorry guys. By the way, Tane is an amazing person. I like Whisper Flow, but I'm never gonna pay for dictating. However, if at any point of time, if you can convert my dictating to an actual agentic workflows, Tane, take my credit card, man. But no, I mean, you have raised hundreds of millions of dollars. You're an amazing entrepreneur. Amazing work. You have literally started this dictation as a space and you own it. So a huge congratulations to Tane as well. Okay, all right. So it says noted. I'll use Tiger as MCP. By the way, you have still not started the code. You're still here. Okay, so it is asking me to, write GitHub webhook secret. And frankly speaking, what I want is, I don't want to give another one. So you can actually go ahead and create your own GitHub webhook. Feel free to search. So basically that's a secret token. And I don't want to create in front of you guys. So I'm going to say, okay, I have already created it somewhere. So let it complete. And I will tell that you can actually use from env file of AI peer review agent. Yeah, let's see what it is trying to create now. plan.md. Okay, perfect. Let's see what it does. Not what it does. Every file has to be approved. I tame my coding agents. They're very sweet. You see, implementation has gone very easier. However, if you don't have the harnesses, you're going to create the worst code of your life. If you have the harnesses right, you're going to create the best code of your life. And right, I'll pause the video, and as soon as it is done, I'll come back to you. All right, guys. So here's what it ended up creating. Now, basically what I want is, I want to look at what it did. After it initialized the Genesis kit, it eventually came to this point and said, where? Okay, here, the done.html. So let's quickly see what done.html looks like. By the way, I will delete my connection string, so don't try to copy that. So this is a locked spec. What is the cognitive job? What is the input? What is the autonomy level? How are you going to tolerate the failure? This is what we are building in general. Then what is the dependency? Which means dependency direction. Every outbound call has a timeout. LM output validated against. Threat model written. One verify passed by a separate agent for every milestone, or every invariant should not be. This is the verifier which verifies. Then for every, what is my phase? What is the demo command that it works? How are we going to use the loop? For example, there are 3 types of loop: build loop and debug loop and research loop. So we're going to use the loop and then try to create it. I'll come to the loop in general. Then skills which we are loading per. For example, for the first milestone, we are loading data system engineering from Agentic SW master model architecture and coding our orchestrator. Then MEM3, where you're using security engineering and distributed systems, etc., etc. So it is using the right skills at the right time. So done.html figures out what is the locked job. Then your Genesis is the one which got unfolded. And then you have this implementation notes. Now what this implementation notes is, as soon as, see, a lot of times your agent sometimes creates something new, even if it is already there. So it checks that what is live right now, which means what is the now in the flight, what is your active loop, what is your current milestone, which phase you are in, is there any blocker. So anytime it creates something new, it will look at this implementation notes and see that nothing is being contradictory. If things is already there, we'll go ahead and do it. So this implementation note is like a live state which is given to your machine or your system, so that you can continuously have a context of what it is building. So even your next guy can actually work on this. Then it has this context graph. Context graph is, let's say that you have one code, right? Which is, what are your invariants? The invariants can be every GitHub work payload passes through a signature. Every webhook delivery is deduplicated via its own delivery idempotency key. Every specialist finding carries confidence and rationale. These are the invariants, which is my business decisions, which is my rules, non-negotiables. I mean, if you know about what are invariants into a system, invariants are something which you cannot violate. So your context graph will contain all these invariants. And then this is something which cannot be violated. Also, your code is given a graph structure, so that if something changes one point, what other test cases must be written so that other does not get affected. So that is your graph. Then you have index. Basically, if you look at this index.md, it contains basically sources, the concepts, how it works, the things which this system has, etc., etc. It acts like a documentation to your project. So this is given by Andrej Karpathy, and amazingly, I am using this into my Genesis kit as well. Then your plan.md is a very, very detailed plan. Basically, what is your approach? For example, we brainstormed a little bit. The approach was modular monolith plus LangGraph plus Tiger Spine. Okay, so one fast API holding webhook increase. This is what we ultimately thought of. Then approach B can be microservices per agent. So there was recently Tariq also talked about, the guy from Cloud Code. He said that if you do not know what you do, what are the approaches to start, you won't be able to do only. So for every milestone, can we figure out our unknowns, something which we are not aware about? So there might be multiple approaches. So first of all, we go ahead with a simple approach for this kind of task, which means chosen is modular monolith, LangGraph orchestration, swap, Tiger cloud, build order prioritizes non-dependent pieces first, webhook ingress, then Tiger data, and then ultimately goes ahead. So for every milestone, it has what is the outcome, what is the phase, what is the files and it touches, what is the demo command, what is the success criteria, what loops it runs, what skills it adds. Basically, this Genesis kit itself gives a lot of skills which is needed, the external dependency which it is dependent upon, and what is the token budget we are giving to complete this particular milestone. You see an amazing structure and how it is done, and several other milestones out here itself. Now, if you go ahead and look at the loops.md, loops.md is an instruction. It's then how AI PR review agent eventually gets built. So basically, before any existence, it runs G0. So it looks at that G0 procedure, which means did it pick the candidate pages by the name against the milestone now? So which means look at the state. Basically, whatever we are developing, we want to know what we are developing because we don't have the context yet. So it picks the candidate pages by the name and against the milestone noun so that it can know that what it is trying to do. It will drill into those existing pages. Initially, they may not be existing pages, but let's say if you come back to M1 after building everything to make it better. So you ultimately will come and drill into that. Then you search. If you're starting something in milestone, there can be multiple things, right? You must have closed your internet. Something must have stopped. So you look at implementation notes to see if there's anything rolling source of truth, what's already live. You confirm that the system does not already exist. Once that all these checks are done, you go ahead and write a G0 checkpoint. G0 checkpoint is basically current.md. Your current.md will contain all the checkpoints, whatever is happening. Then G0 verdict says, okay, it's unbuilt. Okay, if it is unbuilt, go ahead and build it. So every milestone will run this. And then how it is operated. It is cheap by default. We are using Haiku or Sonnet model, and Opus for the expensive, lot of difficult tasks. We have the coding orchestrator to be able to, and then we have several Agentic SWE kit and cognitive skills. For example, we have detective, which actually helps us in debug, verify, which actually helps in check output, blueprint is basically design before you build, scout is basically explore option to solve a problem, counsel and mirror, which is adversarial self-review, ghost is basically shadow and carry, foresight is basically predicting the failures. So these are the skills which I actually made for myself, and I have completely open sourced it, and it works amazingly well. Then for if there are 5 gates after G0, skill, which means did we load the right skills, the router which is needed, the loop required skill, did we log the skills into the checkpoint, did this particular task which we did into that particular iteration, basically to complete that loop there can be multiple iterations, did that particular iteration actually measurably move the milestone forward, and then everything in budget, did we verify the quality, and then did an independent checker and computed based on the demo command. Okay. Now, so the way your loop will work is the 5 loops. Over here, let's say for the milestone have multiple smaller tasks. So it will run a loop. Based on the milestone, it will start a loop. While not milestone is done, and the iterations are less than 10, first of all, you create a micro plan. For the particular thing, you create a milestone specific plan, you load the skills, you read all the wiki pages, you checkpoint the initialization of this milestone, then you produce a micro plan, you write to the checkpoint. Then you create a loop. See, while not milestone done, iterations less than 1, load the skills, load the next phase, see if the phase needs research. If the phase needs research, call the research loop. But if it is not needed, edit files, run the test, see if it actually helps you to progress. If failed, run the debug loop and keep on continuing until you eventually get your milestone done. Once your loop is completed, then you spawn a separate verifier, a separate coding agent that can actually verify if it is correct. And if it is correct, feel free to say, okay, milestone is done. But if it's not correct, spawn the L2 debug, retry just once. If it is not, update in the checkpoint and append the progress to your plan and your basically plan.md and implementation notes.html. Similarly, it will call this debug loop. So everything, even the debug comes in the loop. So if it calls the research loop, this research loop will keep on looping until this task is completed. Right. So you can go ahead and read more about my program Genesis case in detail there, but this is what exactly which will happen. Now, once you have everything ready, you have to go ahead and put this thing into your ENV example. You can ask whoever your coding agent you're working with to help you if you do not know where to get all of this. Great. I've already added it. What I'm going to do, I'm going to say, let's do one thing. Let's say what happened is over. Everything over. What shall we do? Let's say I open a new Claude session. Okay. Fair enough. Let's open a new Claude session. All right. So what shall we do? We don't know. We don't know what we have done. The beautiful part is that look at the kickoff.md. Copy this. Not even this. Anytime. Literally anytime. Kick off. Whatever you're doing. Okay. Okay, I think it did. Okay, great. So if the agents are named not there, it will go to required files now. If you already have something, so it looks for something which is already there. All right, let's see. By the way, this is complete new session, no context, no state, nothing. Great. It creates the checkpoint m1.md. Verdict is unbuilt. So it says definitely yes, your M1 is not yet built. It says starting L1 build for M1. I'll scaffold the project, write the 4 modules with the tests. So now it will start your M1. It should see the problem is that it should ask. I have a habit, you should always ask me before you do anything. But yeah, that was the point, is always start from where you left. So it is going to start off with this, and let's go to backend, and let's go to webhook receiver, and then you have okay, so I'll do one thing. Let's say that, okay, how we'll understand the code. So Genesis Kits gives you an amazing way to understand your code as well. So there's a new thing which I added, and what it does, let me show you where it is. Yes, the kickoff, which means that you can actually put kickoff interview to interview you before you develop a particular milestone. So before you get a milestone, before it even writes a milestone, you can actually write kickoff interview in general. Okay, so the kickoff interview is basically making sure whatever you're going to develop, it produces the right thing. And then you can also call them quiz me. Basically, quiz me is basically helping you to verify whatever the code it has created that you truly understand. So if you want to truly understand, and I suggest everyone to run, so instead of saying, okay, it looks good now, it also runs the thing, but you also say, can you quiz me? All right, so let me quickly show you something. Genesis current.md, m1.md. Now, if you see over here, your M1 progress, ingestion progress, wiki page is red, implementation notes nothing. It was, the verdict was G0. That is the first gate. In iteration number 1, this is what it did. then verify. The next is the verification. Now spawning an independent L4 verify agent with fresh context. It only gets the goal, success criteria, and invariance, not our builder trail. Why? Because we need a separate checker to test. That's why a new agent is invoked. Basically, the work of this, you're an independent code reviewer for a project called, do not write this code, verified code, or do not assume the build logs claims are true. Milestone goal, success criteria is this. What are the invariants? Something which is negotiable, non-negotiable towards what to do to test it. That's it. And then it eventually comes back and then it will say, okay, the M1 is technically done. Now, the beautiful part of this kind of system is basically telling you that, okay, this is what needs to be done. So what I'm going to do, I'm going to quickly show you. By the way, I'm definitely not going to work on all phases. I'm going to work on maybe 2 or 3 milestones, and ultimately, because see, a lot of times you can only complete the milestones by yourself. My idea was to teach you through the system design, so I'm going to develop a couple of more milestones and then let you develop a build on top of it. Because if you just ask me, it's damn easy after that, because the major part you've already done. If you have the right harnesses set up, by the way, you won't get even a single thing if you don't understand how Genesis works. So please go ahead and watch the blog of Genesis. But yeah, I kind of love it. So see, the way it has created that JSON file. You can see over here, which is basically sample PR. And it is reviewing somewhere. The verify approve with one major malformed word validity sign crashes with instead of clean. Let me fix that quickly before. Now, if you see that your current agent said it's good, but your verifier said something was wrong, right? Then it comes back, the debug loop starts, this fixes it, again verifier will check it. It also adds a regression test. What is the regression test? The regression test is basically if something goes wrong, okay? If something goes wrong, did other things also gets verified? If I change something, did other things gets verified? Then you have this L4, which quizzes you as per the protocol to make sure that you understand every single thing, so that you understand your milestone 1, so that you cannot claim that it was not your decision. Why does receive check before HMSE rather than giving the principle should gate all basically given the principle that verification should gate all processing? So it's saying it's a fixed 400 response regardless, so it leaks nothing useful to an attacker. You think signature verification should happen first regardless, and this ordering should be fixed. And not sure and skip, which is an amazing question, and I wanted to answer it. Basically, it's asking a very, very interesting question for the water. So, okay, the question is very, very simple, is what do you do that? Pause this video and tell me. So basically for the first one is obviously that you have a fixed first option, which should be correct, is because the principle was verify before processing. Because we don't want to do any processing before verification. If we do not know that if it is coming from the right source, it eventually contradicts one of our invariant. And that's why we want to say, that's why we should be immediately returning the bad request if it does not matches with our signature, our verification does not occur. So verification first and then processing later. Then we have another edge case. Before the fix just applied, malformed but validity signed JSON cost a raw 500. Is 400 the right response, or should it be something else? You have 2 seconds. 400 response is correct. The reason why we are saying that is because once your HMSE signature has been successfully verified, you are going to already establish that the request came from someone who possesses the shared secret, or somewhere from legitimately from GitHub. So at this point, the request is authenticated. If the authenticated request does not contain your JSON, which is malformed, that's a client error. The returning bad request accurately communicates that request body is invalid.
So the ideal flow is that we verify the HMAC, parse the JSON, and then parse and then returns 400 bad requests and continue processing if the parsing, basically your verification and processing, succeeds. Now, you have another question is also, by the way, that and also, by the way, you can actually chat with if you want to understand. That's why these questions are there. You're not intended to answer it right away. Go ahead and chat about this, right? It will tell you, okay, why are we putting 400? Why are we not putting 500? What are the other benefits of it? What are the security benefits of it? What are the practical? For example, over here, the practical benefits is very amazing. For example, it will prevent your false alarms in server monitoring, because the mal-informed input is not always a server fault. It might be somebody trying to attack you. Or it can actually help you make debugging webhook integrations very easier, and also aligns with the HTTP standards like semantics, which you eventually see. So ultimately, these are for you, the learning opportunity. And more importantly, why are you doing that? What is your approach behind that? And truly understand the code which you have written. Then you have another question, which is change impact. That import the idempotent job router is in memory only. It does not survive a process restart, and it dedupe strictly. Is that acceptable for M1, given M4 will replace it with Redis back dedupe, which is probably correct. Which means the M1 goal is right now is to establish the webhook ingress contract. So what it does, it authenticates the requests, validate the required headers and payload that is coming from the GitHub, route the events, and prevent duplicate processing within a single process lifetime. So what it does, if you eventually go to your, the file and click on your most favorite backend and click on webhook and basically you click on app.py, you can see that what is going to happen is basically that it is the webhook, anything which will come over here. So it will come at this, your request will eventually come over here. So if it is not a pull request, it's going to return an error. But if it is you verify the signature, if the GitHub request is not, you say it's not something which I want, you get the JSON, you parse the pull request basically into the required format, and then you queue that into a job router. Right now, it's all right. In M4, we'll queue that into the our most favorite Redis. All right. So over here, if you look at your router, and what this router does is the real queue, basically it should queue it somewhere. The PR should be queuing it somewhere. That real arrives in our Redis queue right now. But for right now, to get the ingress contract and to end without a broker dependency as per our invariance, it eventually ended up creating a very simple queuing mechanism itself. Right now, very local stuff, which means something until we create our own Redis queuing mechanism, and it is making sure that is this pull request repetitive or not, which means it is checking for is it duplicate or not. If it is duplicate, it is creating an alarm. So what it is technically saying, hey, it might be that sometimes your GitHub webhook might retry or anything of that kind. So it should also check for duplicates, which means it prevents the duplicates right now. So right now it's a temporary thing. We'll ultimately have our durable shared dedupe state via Redis. Right? I'm going to select some of the answers and I'm going to go ahead. By the way, guys, please always use terminal, guys. Do not use desktop, Cloud Desktop, Codex Desktop. All right, so it says your verdict is M1 approve, which means it also approved us. And then as an exit protocol, current.md, plan.md, and progress log and implementation notes is going to be updated everywhere. So great, even the plan.md is going to be updated. Sorry. Hallucination.
Great. Refresh. What is built right now, which is webhook ingress, parse routing. Right now it is queuing the job. Right now it is stub. Basically, we have just created something. It is in milestone 4. It is going to store in Redis. Okay. Known gaps, which means what are the gaps right now? Tiger Cloud provisioning, which is basically service provisioning, and M1 follow, which is job queue is in the process stub. It needs to be replaced with Redis ARQ, the session log. That is it. If you understand, you understand. Your guy can come and then they can start working right here. See what we did? We harnessed it. It's one of the beautiful, and I love it when it does. And I love my Genesis kit, guys. And please feel free to make more PR. And I'll also keep on improving it. Amazing. Okay, so let's go. Let's try M2, and then I will let you to do a lot of the work by yourself after that, right? So let's go. Let's go to M2. Tell me what you'll do first. What you will do first. Oh, let's go to M2, man. I mean, basically what it's trying to do is I have opened a new terminal agent, and so basically our work was that, let me show you. And what happened that my previous service was not working, and that's what I saw. I actually went for the coffee, and then it said, okay, all right, let's see if something needs to be done. So it goes ahead, it eventually says this is the service which is already wired. Your test service is basically I created in front of you guys, but my previous service was paused because of obvious payment issues. So that's why. I told, okay, I can create a new account, and you can actually create a new account, and you don't need to, most of the things are actually free, but you can create a new account which will get you $1,000 in credits, and you can actually use it to create production environment. So go to the Tiger Cloud account using this, and then use my link down below, and then you can actually go ahead and re-authenticate. So you'll be coming out here, which is services. Click on CLI and MCP. Install any one of it. If you're Windows, if you're Linux, figure out by yourself. And click on up here and install the script. Now click on Tiger Auth login. So basically that's what I did over here, is I installed it. I actually deleted it just to show you guys. And Tiger Auth login. And then you can just go ahead and authorize your Tiger CLI, because this will give you an MCP so that your Claude can do a lot of its tasks. So it says all set up, and then it says, let's truly test the services. Now I'm going to say, okay, Tiger service list. Probably speaking, there's no services, right? So, okay, so I'm going to say, hey, I re-authenticated, new account is created. Feel free to use their CLI/MCP to create a service of our choice, same as previous one, and go ahead building M2. As you can see, it is in G0, which is pre-existing flight. So let's see what it does. I'm going to close this loop. I'm going to just wait. It called the Tiger, which means MCP. It is calling the Tiger once again. It is creating a dedicated CPU. As you can see, time series AI add-ons such as timescale DB plus vector, and later we need the PG vector scale as well, as per our design principles. Oops. Guys, this is not needed. It really shown in front of you guys. And you really think that I'm gonna have it? I'm literally gonna delete every services. You can't even see anything. I'm gonna delete that account itself because I no more need that. Anyways, whatever is shown, it's fine. Still at G0. Okay, so it says go to the checkpoint, CM2, the G0, this is the things which is thread, this is the code grep it did, this is account state, this is what on the new service, the table it has created, this decision that binds us, basically immutable. The agent's events is append only and immutable, you cannot change it because we should be able to trace it. And verdict is unbuilt. So it goes towards a loop. So loop L1 build is basically the loop. So let's see what it does. Let's apply the migration directly and against the live service. So your G0 is completed. Now it is going applying migration to Tiger service itself. And we'll see. I mean, let's apply it directly to the Tiger MCP against the live service. And that's what it is doing technically. So if I literally show you what's happening is this memory. Something will be created here itself, and the whole batch role rules are not supported in hypertable, switching to a trigger based append only. So basically, if you see the migrations, basically the scripts and the migrations which is technically doing. So it's creating all the memory shapes and tables which is needed. As per our design principle. Every time I know I'm opening Twitter, something is coming up there in live. Nice. Both update and delete are hard rejected. Perfect. Amazing. You see how beautiful it is doing. env4, which is a context driver genesis, enforced at the database level, not just the convention. Now writing that which is and smoked is that exercise it against the live service. As you can see that every invariance is being followed. That is one of the beautiful part of what we have designed. It is getting the connections, it's going to record the event, and I love it when it follows these things. Then very dumb though. I mean, these are things which you should identify prior itself. All right, let's see how it goes. And feel free to see the tests, by the way. As you can see, the requirement txt is continuously being added. Agent events cannot be deleted as per our invariant. So test data it will live in those agents events, so that nothing is being deleted. Now writing the checkpoint and running L4 verify. Now L4, our different verifier, is going to be spawned to test whether tiger data infra is working or not. So basically something has been done. It says all the gates has been passed, decisions which has been taken, and then running the M4. I love it. Okay. How easy it gets once you have everything harnesses and everything done. But yeah, you have to keep on, it will keep on verifying whether you truly understand everything or not. Okay, so L4 verify tiger data. So you can see out here is basically you're independent for a project call. You did not build this verified code and you do not trust. Tiger provision extension enable agent events hypertable plus continuous aggregates plus relational tables, and finally records HITL feedback created via migration. The success criteria is what are the invariants which is at risk, the non-negotiables. Now spawning an independent, your tiger will be executing an SQL query. Okay. What is the next phase? So let's open plan.md. Okay, let's see, we are living under the budget tokens as well. M3 is write append only rows to agent events for every action webhook ingress basically. So basically for every action for a delivery is curable in agent event. So basically for the observability, we need to be able to quickly pull all the traces, which is correct. And then you have this orchestrator, which eventually fans out and fans in. And then you need an external dependencies here. And then RAG retrieval, HITL gate, post to GitHub, reliability and economics, and minimal dashboard, keep tiny and not over invest. See the power of our verifier. There's one real gap. So I'll be completing with this M2 and you should keep on continuing and it is going to work. So you'll be getting exactly this file and you should continuing with M3, M4, M5 and all the way down to the M until you get your GitHub token up there live. Okay. See here it asks the questions now, but let's say reject agent uses before update rather than a Postgres rule, why was a trigger chosen and what property of a hypertables makes rules unusable here. Take a second, I'm gonna get a water and then come back. Okay guys, I'm back. So tell me more about it. I mean, answer the first question itself. So what does the first question answer should be? It should be the first option itself, which means is based on our design rationale. The rule in the PostgreSQL, they are implemented at the query rewrite stage, which means the timescale DB hypertables internally distribute data across many chunk tables, but they never ever rewrite rules. Which means attempting to create one result in an error along the lines of. So basically, it might create different chunk tables, but hypertable will never ever support this particular rule. So let's click the first one. Now, if you understand why this design, that's how we'll start to understand the code. If you don't understand, don't worry. Chat about this. Go in deeper. Given that I've already worked on the project, I'll be able to make it much more easier. But why did we choose hypertables? See, hypertables will be rejected outright if it tries to write, because fundamentally rules in Postgres are implemented at the query rewrite stage. So hypertables may distribute data but can never rewrite the rules outright. Can you tell me some example of what you're talking about? I should be able to tell you something. Then edge case, which means if a caller runs trunctuate agent events instead of delete, what happens? Does the delete trigger fire? Guys. This was the error which we got after the verifier. And most of you would not understand what it did. And most of you would say, okay, it has fixed. No. You have to understand what happened. That's why it asked this question. So basically, trunctuate is not implemented as a series of delete operations. So it is a distinct SQL command with its own execution path. So anything which is like before delete, after delete row level triggers do not fire and trunctuate. To intercept and trunctuate, you should be having this before trunctuate or after trunctuate right there. So our first is needed a separate trigger itself. It should not be used instead of delete. That was the edge case which we found. I mean, when running from the separate verifier. So there is another question which is change impact. What happens when we change it? Which means there is one design question, there's one edge question, there's one impact question. Which means code chunks is a hard-coded vector, but env embedding different way. If the M6 embedder is built against default without reconciling this, what breaks and where? See, there is something wrong in my env file where embedding dimension is something there, but here the embedding dimension is something here. They're different. So if the embedding dimension does not matches, the PG vector will store their dimension as the part of the column. For example, embedding vector of 1536 dimension, right? But the actual thing is over 256 dimension. The mismatch will happen because the expected was 1536, but because the env file said 256, the mismatch will happen. It will not pad, it will not trunctuate, it will not defer. Amazing question. It will impact my future stuff. See, it identified a crucial issue, and that's what it is asking, and making sure that you know about it. So it's telling, yes, insert time is going to mismatch. Let's change it. Any one of it has to be changed. So it's a configuration inconsistency. Your schema says vector, you have a 1536 which you have written over here, but your environment embedding has a 256 dimension. So that both of the things will not match. Which is env. I will not open, but yeah, in env you have embedding model, embedding dimension 256, which your model will be using to embed your code chunks, but here it is just 1536, so it will not match. So you should keep in mind. All right. So let's do one thing. Let's come back, and I want you to complete everything. Now of course, in the starting of the video, I must have already told you that we are accepting challenges. Whoever completes and makes the best AI PR review agent and extends this particular repo and makes a very nice PR will receive as per our prizes distribution. So whoever completes it, feel free to tag me up, feel free to make a PR, give me the submissions, which is up there in the Google form. Now for the people who want me to see completing all the EMS5, which should not be the ideal case, guys, you should be able to quickly complete every single thing by your own. Have more chat with it. Understand every single decision it took. Get your event spine up and running. Get your orchestrator up and running. Go to Upstash. Create a free account and get the Redis URL up and running. Specialist plus aggregator. RAG retrieval. Every single thing is quite easy. You don't need to do anything. You just need to call it out. Go to Codex. Let's assume I go to Codex, okay? And what I'm going to do, guys, not right now, not right now, is I'm going to click on copy path. Anytime, I don't care what coding agent you're using, I don't care what you're using, terminals, that's it. And fix your ENVs, and you're good to go. Create your Tiger data account, right? I have listed down the PDF. Feel free to use the PDFs to install everything which is needed. Anytime your team starts, anytime anyone starts, the state lives in their thing. Great. Append G0, mark M3S because record event is already exist, but there is no backend observability and webhook ingress. So it is building M3, taking something from the C. It is not trying to implement something new. It will take something which is already being there. Implement. Constraints it will follow. How it will implement. The loops it will run. Alright. So I hope it gives a very good idea. Feel free to go ahead. You'll get this repository up there and feel free to use that. And I hope you will utilize this very sensibly. You will see it's not vibe coding. You're truly lining, understanding every single thing, spent a lot of time into designing this system. I've spent a lot of time in explaining you the system. Okay, so I will see you the next video, and I'm trying to get my videos right. I'm trying to get more of the videos. See, right now we did not focus much on designing every single component. My next set of videos will focus on designing every single component. Coding, Genesis kit. And by the way, if you have designed already, your Genesis kit answer will be very easy. If you have not designed already, your Genesis will spoil you up. So I'll catch up you in the next video. Till then, I will see you around.